Oh, thank you. I'm just afraid because you might maybe someone recording on local machine and we need it on cloud. Thank you.
Good morning, a very good morning, everyone. I hope I am audible. And a warm welcome to all of you joining us for Module 5, Foundations of Quantitative Research. My name is Sibusisiwe Mkhani. I am a chief researcher from the HSRC, and I will be chairing this session today alongside my colleague also from the HSRC, Kukhanyile Mali, who will be serving as the technical facilitator today. I must say I'm very excited about this session, and I really look forward to the presentation that we'll be hearing today. And I hope everyone shares the same interest because we have a very rich and engaging learning experience ahead of us. And you know that the reason why I am looking forward for this presentation is because I know from the personal experience that for many postgraduates and early career researchers, engaging with quantitative research can feel overwhelming at times, from navigating the different study designs, identifying variables, to understanding how to interpret the statistical outputs. And however, I also know that with time and guidance, these foundation tools or skills become powerful tools to produce credible research. So I know this session here will also help us to strengthen these very foundations. So today's sessions will run from 9 o'clock to 1 o'clock with a 30-minute break. And I encourage all of you to engage, ask questions, and make the most of this valuable learning space. And without further wasting any time, I would like to introduce our presenters for the day. And we are fortunate to have a great panel of highly accomplished presenters for this session from the HSRC. Each of them brings deep expertise and practical experiences in applying quantitative research to address some of the most pressing challenges in our society, from education, urban planning to labor markets, poverty and inequality. I must say their full bios and contributions are honestly too rich to cover in detail here. We would spend half the session just reading through them, but allow me to briefly introduce them. So we have Dr. Vandudzai Mbanda. Dr. Mbanda is a senior research specialist in the HSRC EEE division. She is an economist with over 15 years of experience working on poverty, inequality, unemployment, and food security. She currently holds the or leads the HSRC One Food project, which integrates human and social sciences into one health approaches. Welcome, Dr. Mbanda. And we also have Mr. Zakir Asmal. Mr. Zakir is a research manager at the HSRC with more than a decade of experience in labor markets and skills development. He holds a master's in economics science with a distinction from VETS, and has contributed to national initiatives, including South Africa's labor market intelligence program and research for the World Bank and various government departments. Welcome, Zakir. We also have Prof. Justin Visahi. Prof. Visache is a chief research specialist at the HSRC and an associate professor at the University of Free State. His work focuses on urban economics, spatial data, and inclusive development. He has led major projects for the World Bank, National Treasury, and local government, and has published widely on migration, firm productivity, and housing. Welcome, Prof. Visache. And last but not least, we have Dr. Andrew Joan. Um, Dr. Andrew is a chief research specialist, also from the HSRC Triple E Division. She is working on the Education and Skills Development Program. She holds a PhD in Policy and Development Studies, and her research focuses on education, policy, governance, and large-scale learner assessments. She has led the South African team's study since 2011 and is co-principal investigator on the longitudinal study on youth leadership. So welcome, colleagues. We are looking forward to your presentation. And before we begin with the presentation, ladies and gentlemen, I would like us to go through some housekeeping rules. Just quickly, I would like to mention that Kukanyile will be monitoring the chat and helping ensure your queries are addressed. And if you have a question during the presentation, please, you are welcome to type in the chat. And alternatively, you may wait until the presenter has finished their section, then you raise your hand and ask the question. However, we will also get an indication from the presenters on how they want to take the questions, whether they want to take it after their presentation. And please, colleagues, keep your microphones muted during the presentation to avoid any background noises or disruption. And also, Kukanyile will be sharing an evaluation form on the chat. Also, please make sure that you visit the link and evaluate the session for today. Thank you so much, and I'll now hand over to the presenters to start with their presentation. Thank you.
Thank you.
Okay, Andrea. So I'll share the screen and then I'll introduce the different presenters as the different sections come on, and then I guess I'll be in control of the presentation. Is that correct, Andrea? Or would you prefer to have each presenter
No, I
control
think
their
one
slides?
one person is fine. So for the poll and the quiz, I'll just take over and present from my side.
Okay, I'll share my screen now. Okay, can you see my screen?
Yes, just put it into presentation. Great.
Okay, thank you everyone for attending the session. It's quite a jam-packed session, but we want it to be as interactive as possible. So please do raise your questions in the chat as we go along. Specific presenters may have preferences for how they engage with you or answer your questions, but let's just go through the learning objectives first. So what we want you to come away from this module is to understand the core principles and logic of quantitative research, and then to identify different types of quantitative research designs, recognize key variables and how they're measured, interpret basic statistical outputs and visualizations, and then just briefly introducing how AI can assist in summarizing, interpreting, and visualizing quantitative findings. I think the important thing to also just take away from this is that this isn't a hardcore stats module. We really are thinking more about the logic of quantitative research, when to use it, how to use it, how to think about quantitative research. So you don't need to have like crazy background in stats or anything for this module. We just want to get you thinking about quantitative research. And then there are other modules in the program of the Academy where you can pick up some of the items that we'll introduce today. For example, there is a module on secondary data analysis, as well as I think another module that deals with statistical analysis. So we will just basically be getting into the concepts, introduce you to them, but we're not going to do anything too crazy statistically here. So I'm going to hand over to Prof. Justin Visagie now. He'll take us through the first section, which is introducing us to the idea of quantitative research and how it differs from qualitative research. So yeah, you can come in, Justin. Thanks.
Sure. Do we keep our cameras on, or do we worry about bandwidth?
I think you can keep them on for a little bit, Justin.
Okay, so it's good that you can see my face. So, yeah, what a privilege it is to talk to almost 300 of you. We really do just appreciate the time that you've set aside. But 4 hours on Zoom is also a daunting task. So I'm going to try and put as much energy as I can into this next little bit. We also want to have some fun. And so in response, please interact with me. I think it's also useful to say that most of us facilitating today, I think all of us actually, are from the Human Sciences Research Council. And so this is an organization where we're not just talking about the theory of research, but we actually do applied research for a lot of clients in the real world. So all of us have a passion for, not just what the textbook says, but why that textbook matters and how to make it come alive. So we really hope that this sort of quantitative session today won't be something that feels dry and cold, but something that really comes alive. So yeah, we'll try and make it accessible. We don't expect you to be all economists or statisticians. My background, I was introduced, yes, I am an economist. I do love stats. I do love data and numbers, but actually I also love qualitative data, as I've learned and engaged with some of my other colleagues. So if you're from a whole range of different backgrounds here, I hope you feel welcome. Certainly, we don't want you just to sit back and watch. We don't want to just regurgitate theory, but what we want you to do, and for my little section, I'm going to frame it from my own perspective as an urban economist, which is thinking about, let's think of a question, right? So my research question might be something like, I'm interested in cities, and a big issue is people moving into cities, and they've got nowhere to go, and an informal settlement or a slum is often their only option. So perhaps an interesting research question for me would be, do those informal settlements allow people to sort of get ahead? Can they act as an escalator where someone moves to a city, they can at least find some work, and maybe they can move in and eventually upgrade and move out? Or do they act as a dead end, that you go into the informal settlement and there's no mobility and you get stuck? So I'll try and refer back to that example as we talk through some of these issues today. But I want you to think about what your research question is. It's really useful as you go through these different modules and courses to be thinking about your research, what it is that you're interested in. And of course, from that question comes the tools of today's modules, which is, what can quants do to help you unpack the thing you're interested in? But also, what can't it do? So, it can do some things, can't do others. And then how best can you use it? So we thought that, next slide, we thought that the best way to start today would be to have, is that a quiz?
No, I'm just saying that the session's being live streamed to Facebook. So if you know anyone who's battling to get in, please just send them to our Facebook page.
Perfect. Thanks, Andrea. Okay, so I thought we'd start with something a little bit more philosophical, but hopefully a lot of fun too, which is what's the difference between qual and quants? Well, one way of looking at it is saying qualitative feels more like Oprah and quants feels more like Spock, for those Star Trek fans among us. Next slide. But there are some serious differences between qualitative and quantitative research. Here's some nice examples. Quantitative method would feel, and quantitative approach would feel something like this. 20% of survey respondents bought ice cream today, or the average amount spent on ice cream by 500 respondents was $5. So you can see it's very defined, it's very measurable. There's sort of data and numbers behind it. But a qualitative approach would feel something like this. I bought the ice cream because I saw it when I was in the checkout line and I wanted to treat myself. It's also very valid, and it gives you quite a different sort of information about ice cream, doesn't it? What about another example, a pizza? A quantitative would sound something like this. 50% of people in New York 50% of people in New York strongly enjoy pizza, whereas a qualitative approach would sound something like this. I like a lot of toppings on my pizza: cheese, sauce, pepperoni, olives. Now, both of them are telling you different sorts of things, and both of them are valid in their own way and their own context. Last example here. On average, respondents rate their grocery store a 3.5 out of 5. Or, from a qualitative perspective, the grocery store has good options in general, but the lines can be long and they are often out of stock of my favorite brands. So I think we all kind of get an inherent sense of what we're talking about between quantitative and qualitative, and they both do different things and both are valid. Next slide. I like this diagram. I think it also sort of says something about the different approach, where, qualitative research, you might interview 10 people and uncover 100 things. All these complex nuances and the context and different motivations. It's a whole world out there. So qualitative research, let's go back to my example of informal settlement and upgrading. You might have a focus group where you talk to people about the experiences of living in an informal settlement. Why did you move there? What motivated you? What do you feel your prospects of the future are? And you'll get rich, in-depth information, which will give you a whole lot of ideas that you never thought about of why people are moving there, what they're doing. So it helps you explore and understand the world in a rich way. Whereas quantitative, if we look at the yellow figure, is you survey 100 people and you validate just 10 things. So, the quantitative generally is a lot more people being involved, a lot more number points, but actually at the end you're kind of focusing in on a specific dimension, saying specific things. And so we need both, is kind of my comment today. Next slide. So of course we can also mix them together, and that's really exciting. And in an environment that, like the Human Sciences Research Council that I work in, is one where you've got a sociologist and economists in the same room, and that can lead to a lot of fun. It can lead to some tension, but ultimately, I think the best research, or exciting and innovative research, understands both ways and gets the best of both worlds. So let's say a few more other things about contrasting quants and qual. So, the goal of qualitative research is often to generate hypotheses. You're trying to understand and why things are happening and how they're happening. So it's sort of depth. Whereas on a quantitative research method, you're often trying to test hypotheses. You already sort of have an idea about how things are working, and you're trying to use the data to see whether that actually pans out overall, across your particular sample. So much more narrow focus there. The setting in qualitative research can be sort of natural. You can't sort of control it. It's not Whereas in quantitative, ideally, you're trying to have experimental kind of design where in some ways you are trying to control different factors and things. The sampling is also very different. In quantitative, we want a random sampling, and we're going to talk a little bit about different approaches to collecting quantitative data and to the sampling design. But it's really important because ultimately with those numbers, you want to say something authoritative about what's happening in the general population. And so the sampling matters. Whereas in the qualitative research, it's often a little bit more purposeful is perhaps a word for it, where it's a much smaller number. It might not represent everybody, but it certainly represents those individuals, and those experiences can then help you generate hypotheses for what might other people think and feel. Okay, and the data collection then happens in different ways. So with quantitative, we're talking about surveys, we're also using administrative data, other sources, whereas in qualitative, you're often going into the field yourself with interview guides, focus groups, etc. Yeah, I think I've said enough about that. Right, next. Okay, so just now, I hope we've kind of had some fun thinking about the difference between quantitative and qualitative. And today's session, we want to focus in on how we can use quantitative tools. And so I've just put down some reflections from my side over the years of when quantitative and economics is sort of my background, my discipline, which is very quantitative. When is it useful? Because it really, I'm passionate about economics, passionate about data, because it can do some fantastic things in terms of us understanding the world. I think the one way that it's useful is that it is pragmatic, right? It's kind of like applied. You've got your data, it's pretty straightforward. Trying to pick your tools. Of course, the more you go into it, the more you realize nothing is straightforward, right? There's always choices that you have to make. But certainly in qualitative data, it's easy just to feel overwhelmed. Where do I start? How do I make sense of all of this? I don't envy my qualitative colleagues, or at least with quantitative data, it feels like we've got some tools in our toolbox. Let's try and look at some descriptive statistics, look at some correlations, and ultimately move towards causation. It helps us sort of move along and do stuff. It certainly feels less intimidating for someone like me. The second thing about quants that I think is really useful, and maybe most importantly, is the power of data to tell a really good story. So, going back to my informal settlement example, you can say something with a qualitative story, which is really important, and you uncover, say, for instance, that people in your focus group felt that informal settlements were a dead end and that there was no hope, that they move into it and they get stuck. And they give you all sorts of emotive words and language, and you can really tell a rich story. And that's cool. But I think in terms of influencing policy, it's also really cool and also very valid for you to say something like this, that 10% of individuals living in informal settlements in South Africa earn more in the next 5 years, earn more in 5 years' time than when they first moved in, right? Only 10%. And that tells you something really authoritative to say informal settlements are not working. Whereas qualitative might suggest that, yes, this general sense where people were frustrated, their lives aren't getting better. Quantitative lets you unleash that data to sort of put a statistic onto it and really say that this is happening overall for the country, and that empowers policymakers to sort of prioritize and do things. So I think that's why quantitative data can be really powerful. It is pretty flexible as well and innovative. There are lots of different ways of us trying to approach the question. Of course, we're not trying to go into an advanced methods with you today. And I'm a big fan of just doing the basics really well. I think a good descriptive statistic, the one that I quoted earlier, is just a descriptive statistic saying what proportion of people had improved their life chances over a 5-year period. There's no fancy model. It's just pure description. What percentage of them did it? But I think it's accessible. It tells a lot. It's an excellent starting point. So yeah, really, really, really great. But of course, we've got other options to sort of dig deeper. We can combine and say, well, was it only people? Was it all people who had a 10% chance? But what happens if we look at a subset of foreign migrants in informal settlements versus the indigenous population, and do we see a big difference? Maybe you find that for foreigners, actually there's a much higher mobility or a lower mobility. So we can slice it, we can dice it, we can do a whole lot of cool stuff with data to sort of, unpack how these relationships work. Okay, going even deeper with quants is ultimately the search for causal relationships. So, where in general I find qualitative researchers want to sort of say, it depends, always depends on this context and this factor. In economics in particular, we're trying to sort of look for that golden thread, that actually there is a real causal mechanism that goes on. And yes, it simplifies the world, and there's dangers to that. But still, understanding these different causal mechanisms are really powerful, different levers that you can pull. Is education and training a way for people living in informal settlements to improve their life chances? Is giving them a social grant? You can think of a range of different interventions. Which of them work, which of them don't? If we've got data and we can generalize for the population, we can start to answer that. So quants is really useful to empower us to do so. And I think at the end of the day, it encourages a kind of systems thinking about the way the world works. Is that, are these kind of mechanisms that are going on, and that if we uncover these mechanisms, ultimately we can sort of tweak, and we can cause a systems change. Maybe another way of saying that is, we all come often to the world with our biases. We sort of, maybe you believe that people in informal settlements are just there because they're lazy. Or, you can have all sorts of actually prejudice. We can even have racism in the way in which we view our society and our world. But I think from a quantitative perspective, it's encouraging us to understand that people are responding to the incentives that they're in. They're particular, maybe they appear lazy, but actually it's the context which they're living in, which actually kind of causes the decisions that they make. And I think thinking about the way the world fits together, these different forces, I think is a really important way of just understanding society. Great. I think I've said enough about that. So I've said about what way in quants is really useful, but I think it's also at the start of the session today worthwhile just pausing and thinking when it's not so useful. And we've kind of already started to allude to that with the qual versus quants slides earlier. And I think as quantitative researchers and those who are using quantitative methods, we need to understand what the limitations are. And that helps us, make sure that we're doing research that's really meaningful and impactful. I think the first thing is this kind of illusion of objectivity. While it is an applied science and we'd like to think, we're not ideological, ultimately, you always are going to be making decisions. You're always going to be choosing some variables rather than others. At the end of the day, we like to think that in quants we can be more objective, but there's always a subjective element going on. And I think that, it's at least the qualitative researchers know that they're working within the subjective world. I think it's really dangerous when quantitative researchers, sort of have this illusion that everything's objective, but we can never really move away from that. So that's the first danger. I think the second, and this is really key, is this danger of oversimplifying and generalizing. So, at the end of the day, we are generalizing. We're trying to find statistics to show us how relationships work. And it's simplifying, it's generalizing, it's trying to understand those mechanisms. But of course, those mechanisms won't work if a whole lot of other contextual factors aren't there. So in our informal settlement upgrading, I can quote the stat, only 10% of people got stuck. 10% of people upgraded. But maybe if there was a slightly different context, maybe if you're talking about an informal settlement that's actually not on the peripheries of a city, and maybe my data I'd sampled an informal settlement that's close to jobs, maybe you find that actually it's a fantastic springboard. And so there's a danger that, now we all of a sudden write off informal settlements, that there's no, they're all bad, when actually they still, in certain contexts, could actually serve as really good levers for mobility. So yeah, we are oversimplifying, we are generalizing, we need to sort of understand the limitations of that. Context will still matter, and that's the kind of dance that we have to do. Another thing that's dangerous is doing the PhD in the obvious. I can't tell you how often this happens. And the quantitative person does a whole lot of fancy models to tell us something that, in the end of the day, is pretty obvious, pretty straightforward. So, it's not just about applying tools for tools' sake. what are they trying to do and achieve with these tools? Yeah, and I think another really key thing about quants that can go wrong is we can have a weak theoretical and conceptual basis. So, it really doesn't help to just throw all these fancy models and things at something, and you kind of left wondering, like, what's the point? What were you trying to do? Why are you applying these models? Why are you picking these tools? So the research question can be a mess. They can be we still need to engage with these ideas, concepts, theories, and then that forms the basis for forming these hypotheses that we can test with our data, etc. But certainly, I've attended way too many presentations from students where you're just wondering what's the point? Like, why did you choose these things in the first place? And sometimes it's because there's weak engagement with with the literature. So even though we're passionate about data, as academics, as thinkers, the world is about ideas. Ultimately, we need to have a rich engagement with ideas, and we need to use these quantitative tools to either strengthen the ideas, the hypotheses that we have, or reject them. But we need, there's a danger that we move away from theoretical engagement. Still really important, even for quantitative researchers. And I think understanding the why, and my last point there is a little bit more directed at economists. You can have a whole lot of faith in markets, but not actually ask the question, well, if the market outcome is so bad, surely we need to do something about the conditions that set the market in the first place. But let me leave that aside. So you can see my little nice, I think it's a far side comment on the right. I think that this is far too true of too many economists and quantitative researchers. Ultimately, we put the cart before the horse. The tools that we're going to show you today, thinking about quantitative methods, is ultimately to serve the purpose of what your research question is, to explore the world and to make sense of the world. It's not data for data's sake. It's not methods for method's sake. It's not quants for quant's sake. It's actually the quantitative tools that can help us unlock and understand the real world better. So I really hope that your engagement with our course today is going to give you and sort of start you on your journey of being a sort of better academic when using your quantitative tools. I think, let's see the next one. I've got a bonus for you. Do I have time for a bonus, Andrea? And sorry, Zakia, are you chairing?
Yeah, go for it. I think we have time.
Great. So a little bonus slide for this section today is something that's quite, what's the word for it? Sexy today in academia is words around interdisciplinary, multidisciplinary, and transdisciplinary. So we've spoken about qual versus quant, but what about these other terms that we're hearing? What do they mean? Next slide. Okay, and I think we've got some cool little diagrams to talk about this. Disciplinary research is essentially, we can look at the same question, let's say the issue of informal settlement upgrading and mobility, but each of the different disciplines will apply their knowledge to the question in their different ways, and the boundaries don't actually blend in any way. So, that's like we're staying in our disciplinary lanes. And there's a time and a place for that. Multidisciplinary research is where actually there is multiple disciplines. And maybe the questions, qualitative researchers, for instance, could be uncovering certain mechanisms, and those hypotheses could be getting tested by economists in different contexts. So we're still not really blurring the lines between them. We're still staying in our lanes, but there is some sort of thematic mixing and blending that's going on. Interdisciplinary is where you are actually crossing the boundary. So that's where I am being friends with my sociologists, and we're trying to do the research together in a more dynamic way so that we can sort of develop knowledge in an integrated fashion. A mixed method approach, for instance, where you're having qualitative focus groups combined with your field work with a survey and blending those methods together, Mixed method, that would be it could be an example of sort of interdisciplinary, using skills from economists and sociologists together. And then there's a last word that you'll sometimes hear today called transdisciplinary research. And what is that about? Well, transdisciplinary essentially means you adding in the community in which you're engaging with. So, you know, historically, researchers have always wanted to be sort of arm's length from the communities in which they work. So in my case of informal settlement upgrading, the community it would be the practitioners and government who are responsible for the policy and providing services, and the communities themselves who are living in that informal settlement. Transdisciplinary research would see them as also having knowledge with which we can contribute. So we don't just do science for society, but we do science with society. And other words that they use in transdisciplinary research are things like co-creation. So how do we actually find out, set the right agenda in the first place? You know, we might come with a whole lot of predispositions about what the objective is, but transdisciplinary research from the word go involves the community to actually help us set the right questions. And so we talk about co-creation. We also talk about words like co-production, that actually in doing the research that the various stakeholders can have valid points to make. So that's something about how the world is changing. And I think what you'll find is in a career in academia, and as you advance your sort of knowledge as a scholar, is that we're moving to a place where actually we want to try and blend all these things together. So I hope that this kind of introduction has sort of provided a good foundation. We are focusing on quants, but at the end of the day, it's quants plus, right? Plus qualitative, plus different perspectives, plus, you know, as we move to a more blended and integrated and rich world. And yeah, so I think that's enough said from me.
All right, thank you so much, Prof. Thank you so much for that very insightful overview of what quantitative research is, and just as importantly, what it is not, and how it is different from the qualitative methods. So I think we can pause here maybe for a few minutes, but you will let me know if you would like to take some few questions now. Or maybe we can go to the next session and then we can take few questions. But if there's anyone who has questions, they can raise up their hands, or you can drop your questions on the chat. So Prof, do you prefer us to have questions now, or?
I think let's take some questions for about 5 minutes or so, and then we've got a quiz from Andrea. So if that works for everyone.
All right, thank you, Prof. Kukanyele, please help me with the questions on the chat, and if there's anyone who'd like to ask Prof a question, they can raise their hand.
Wow, it does take a brave person with a big room, but it's nice just to have a couple of comments. So we've got 3 hands, and then we're going to have a quiz, so that'll be fun to involve you all. So I see Lufuno. Do you want to unmute?
Yes, thank you, Prof, for this very insightful introduction. For me, it was very useful. I just wanted to check with you if there has been a case study where somebody was able to do a research in a way involving these approaches you have given us in the bonus. What is this now? In the bonus slide, yes. And I also wanted to check, like, if you know, maybe the universities that are more open to maybe somebody being a lawyer and wanting to do something that also involves engineering, for argument's sake, where you can do let me give an example with myself. Like, I specialize in cyber law. So being in cyber law, then I got to know about issues around climate change, ESG, and we also specialize in cybersecurity. And if you were to look at it holistically from a digital transformation perspective, you can't necessarily look at it from a cyber law perspective alone, because you do need the cybersecurity part, which might be in the engineering space, and you do need the ESG part, which might be in an environmental space and stuff like that. So I'm just trying to find out if there are cases where universities are open for such approaches, and also to find out if HSRC, how do we get involved with HSRC if I want to do research like that, as an example. Thank you.
Great, Lufona. I'm glad that I've inspired some energy and some interest. My experience is that, yes, universities very much are moving towards the frontier of interdisciplinary and even transdisciplinary methods. I think it's something that's attractive in the marketplace if you can develop those skills. As the Human Sciences Research Council, our mandate is really to do applied research that sort of makes a difference in the world. So we don't teach or offer courses. Well, here we are providing some teaching and training, but we don't confer degrees, let me say it that way, even though of course we do contribute here and there to learning. But our main focus as the HSRC is on applied research. And what you find is that actually a lot of clients and that you're doing work for, benefit from actually having a team which has a range of different skills on it. You also find that certain research organizations can have a specific grants. So I, for instance, have done a project for the International Science Council. It was on upgrading informal settlements, and we were looking at the fact that you get very dense informal settlements close to jobs, and how can you sort of harness that density to promote well-being. And it had a team which had practitioners who worked in the informal settlement. It also had some architects and engineers. It had myself as an economist, etc. And we came up with a sort of double-story, low-cost housing design. So it was very out of my comfort zone as an economist, but really rewarding because we're sort of combining these disciplines together. So the answer is yes, this does happen in the real world. It is encouraged, and I think that you would find your university supportive in developing those sorts of skills. But often it can be project-led, right? Because if you've got project and you're responding to a particular call for proposals, then the team that you're assembling, you get a diversity of skills. I will see if I can put in the chat some links to resources about transdisciplinary research so you can do some more reading. Thanks. Great. Maybe we can just, if I can take two more, so we just try and keep your questions short so I can at least have some room for others. So I think the second was Chube. Sorry if I don't pronounce your name correctly.
Thank you. Thank you so much. Jobe is my name, following from Zambia.
Welcome.
Yes. You mentioned one of the dangers of a quant research has weak theoretical or conceptual frameworks. And yesterday we heard about the use of theoretical and conceptual frameworks in this research. I just wanted to get it clear maybe from you, since you are actually specifically talking about quant. How do we actually use a theoretical or conceptual framework in the same study? Could there be an example, or if there's a journal article which you can just throw in so that we just really see how we use a theoretical and a conceptual framework in there, and to make it strong so that it's not weak? Thank you.
Yeah, it's a great question, and I think worth saying a few things more about it. So The conceptual framework often then will inform the questions that you're asking of the data, right? So in the example of people moving to cities, trying to enter an informal settlement and improve their livelihoods, maybe the economic theories there could be around migration and urbanization, and the fact that people are supposed to move from farm, agricultural places to factory, and their theories. I'm trying to remember the offhand. I think it's the Lewis model, who sort of predicts that as countries sort of move along in terms of their structural transformation, that they move from more agricultural to more industrial. And in that process, there's the sort of urbanization that occurs. But then there are other theories, can't remember, but essentially, then you can, in your literature review section, you would be engaging with how people assume the world would work. And of course, the question is that, yes, people are supposed to move from farm into factory, but maybe there's an issue that the economists are assuming away, the fact that there's unemployment. So some economic models just think that everyone can just get work, that the labor market clears. And that's certainly not the case. So, your quantitative tools can then actually start to explore, even in contrast to what the theory says, and then that can lead to new theories and new theorizations. But I think it's important in any study that you obviously have your literature review part, and that literature review part has the aspect of ideas, concepts, how is the world supposed to work and why does it work in that way, and then you can have in the same literature review other applied quantitative studies where people have tested. But ultimately, you're not just doing your study and saying, I've got data and I'm running my models. Like, why are you doing, what are you searching for? Who else has done what? And how does it inform the choices that you make? So it's really important that we don't sort of just do quantitative research in isolation from understanding both theory, how the world is supposed to work, as well as understanding what methods to choose and what other people have done to test it. And that kind of then frames your research. But it's a great question. I hope that's a good enough response. And of course, qualitative research can sometimes help us ask the right questions in the first place and then test them with quantitative methods. I have one more, I think, we've got time for. The hand I see, I'm sorry if you're not third in the queue, but the hand I see is George Abiri.
Yeah,
Thanks, George.
Thank you very much, Justin. This is George Aberi from Kenya. Now, mine is just an observation. There has been this problem of compartmentalization, in which case many researchers say, like, if I am a pure mathematician, I want to still remain in mathematics with the pure fear that if I venture into interdisciplinary transdisciplinary research, I might be said to lack a disciplinary home. But as we speak, I think as you emphasized, especially when it comes to collaborative research and coexisting in the current world, in academia, you need to move beyond your disciplinary boundaries. That is why I was saying it's a commentary, because it isn't a must that we stick to only those areas where we are professionally trained to work on, but also to venture to these other areas. And the way to go in the future is to embrace these interdisciplinary transdisciplinary approaches. Because if we stick within our cocoons, I'm sure to have to confirm that the world will move forward as we stick to, as we remain behind. Thank you very much. Mine was a commentary as opposed to a question. Thank you very much.
Thanks, George. Yeah, I completely agree. And I think we become better researchers if we don't stick our heads in the sand, but we try and learn from others. So maybe you are a quantitative person and you'll get a chance to have some exposure through this academy to some qualitative methods. That's great. Expose yourself, learn, see from other streams. Similarly, you might be in this session today because you're a qualitative researcher, but you want to understand something about what quantitative research has to offer. I think it really is of benefit for us to be exposing ourselves. That's not to say that there's not a place for doing the pure mathematics and the pure economics or the pure whatever stream you might be in. I think there's a time and a place for that. But certainly it is really exciting when we can start to blend some of these boundaries. And that's certainly the way in which the frontier of science is moving towards. Ultimately, we want to be relevant, right? And solve problems in the complex real world. And we use all sorts of tools from all sorts of different angles. Sure, this session is dragging on, and I fear we must definitely keep the ball rolling. Thanks everyone for the conversation.
Okay, thank you, Justin. Please do keep your questions coming in the chat. If we do have time later on, we may be able to revisit it. For now, though, Andrea, would you like to take over with the quiz? Would you like me to stop sharing my screen, or?
Sure. And Justin, you can also just add to some of the answers we've been giving in the chat live. Morning, everyone. I can just have a second to get this. Okay, everyone. So if you can get your phones out and scan the QR code, or if you are using your phone to join and you can't scan the code, just go to your browser and type in slido.com, and it will ask you for a number, and just put in 1376811. So if you have your phone spare, just scan the QR code. If not, open your browser and put in this code. So this is a short quiz. It's testing your knowledge, but we will cover what we're going to test later in the module. So I'm just going to explain a few types of research design and get us into thinking in sort of a quantitative way. So we're going to be looking at 3 types of research approaches. And what I'm going to do is give you a research scenario and ask you which type of research approach is more appropriate for that question. They will all have the same 3 options that you can choose. The first is a descriptive research approach. So descriptive, we describe the characteristics or patterns in a population. We don't investigate relationships or causality. So we're just saying what the population looks like. For example, 40% of South Africans feel that they are addicted to their cell phones. So that's describing what's happening. We don't know anything that's linked to it or anything that causes it. The second is correlational. So correlational designs examine the relationship between, excuse me, 2 or more variables, but we're not manipulating the variables. So, for example, do more hours of sleep affect energy levels? So there are two different variables we're looking at: hours of sleep and energy levels, and we're looking at the relationship between the 2. And then lastly, experimental. So an experimental design tests causal relationships, so it's building on the correlation, but we randomly assign participants to different conditions. So we have a control group where they do not get a treatment or an intervention, and then we compare this control group to one that has the intervention. So an example of this is a new type of teaching method. So teachers are taught to teach differently, and we have two classes of learners. So one class of learners, we look at their achievement levels, but we don't expose them to the new teaching method. The other class of learners who are similar, we do expose them to the new teaching method, and we can compare the achievement between the classes to see whether there is a difference or the teaching method is making a difference. So it is an experiment between two groups. Okay, so try to keep these in mind. Don't feel disheartened if you're mixing them up. We will go through them in detail a bit later. Right, so we have 130 participants so far. That's great. I'll wait till we get to 140. No? Almost there. Okay. So the first one, what is the average age of students enrolled in an MBA programs in South Africa? Is this descriptive, correlational, experimental? You have to be very fast. You've only got 20 seconds. All right, so most of you got in. Right, so 74% said descriptive, right? So we are only looking at one variable, and that is age of students. And we are describing the age of students. So we're looking at the average age of students. So that is the correct answer. I'm trying to think of how we could change it into a correlational experimental. The other presenters can come in if we were to change it. But just on face value, this is a descriptive question. We want to describe the age of students. Okay. Is there a relationship between time spent on social media and the academic performance among high school learners? Great. Okay, so you're really getting the hang of this. So correlation is correct. So we're looking at two variables here, time spent on social media, and the other one, sorry, there's just a hanging box here. The other one is academic performance among high school learners. We're looking at the relationship between them. So we want to test whether more time spent on social media leads to less or poorer performance, or the other way around, or maybe there's no relationship. But we're looking at two variables and how they're related to each other. Next question. Does implementing a flipped classroom model improve grade 9 learner scores compared to traditional teaching? Great. Okay, so this is experimental. We're looking at two groups of the learners. So those who follow traditional teaching methods or exposed to traditional teaching methods, and a treatment group who will be exposed to the flipped classroom model. And we will compare the mathematics scores of each class. So this is an experiment. Does exposure to violent video games increase aggression in teenagers? Okay, so a little bit of a mixed method, so this one could be I've got experimental here, but it could be correlational. So we're looking at two variables, exposure to violent video games and aggression as two. But we could make it experimental if we compared two groups. So those who were exposed to violent video games versus those who weren't exposed to violent video games. So we'll give the correlational and the experimental the right answer here.
I mean, I think
What
it's fair,
is
Andrea, it's fair to say,
yeah.
it's a good point, that sometimes the methods that you eventually choose help you
Yeah.
know which box to put it in, right? So
Yeah.
the scholars out there are right to sort of wonder, which one should it go in? Because obviously, if you once you know the sort of method, then you know whether it's just correlational or experimental. It could even just be descriptive at a start. So,
Right.
yeah, so I think it's good. Thanks.
Okay. What percentage of university students use generative AI tools on their assignments? Right. So we are just looking at describing the population here, so the percentage that use AI tools. So descriptive is correct. But if we were to make it correlational, we could look at the relationship between use of AI tools and university achievement scores. So have two variables there. Right. Is there a relationship between school attendance and academic achievement in rural schools? Great. Yeah, so two variables here, and the relationship kind of gives you a clue. So the variables are school attendance and academic achievement. But by putting in rural schools here, we're defining a context. So we could actually compare it to urban schools, students in urban schools, and then that would be experimental. Right. Are there differences in academic performance between male and female learners in mathematics? Okay, so a little bit of a mixed bag here as well. So what is the question asking? It's asking about differences. And we have male and female. But if we read the question, is there only one variable that we're measuring? So yes, the only measurement we're doing is academic performance, but we're describing the performance for male and female learners. So this is actually descriptive. We're not looking at the relationship between males and females. We could argue for experimental. I will give those that are thinking in that way. So comparing male and female academic performance, but there would be some kind of intervention that was needed. But just on face value, this is actually a descriptive. So when we are what we call disaggregating data, so breaking up data into demographics, so we can have age ranges, we can have gender or sex, or regions of a country, even though we are breaking up the data into these groups, it is still descriptive. Okay. Does providing career counseling improve students' clarity and goals compared to students who don't receive it? on future goals. Sorry, there is a box above the one corner that keeps blocking out words. Right. So what are we looking at here? Career counseling seems to be an intervention. Future goals are what we are measuring. That's our variable. And then there seems to be a control group here. So we are comparing those who receive counseling versus those who don't receive counseling. And we're comparing clarity on future goals. So this is an experimental research design. Great, I think we're almost done. Is there a relationship between student motivation and their performance in mathematics? Great, so you're really strong on the correlational research design. Yes, we are comparing the relationship between two things, student motivation and performance in mathematics. Great. Okay, what is the most commonly chosen major among humanities undergraduates? Great. This is descriptive. So we're just describing the population of humanity graduates and looking at the most commonly chosen major. Okay. Great. So 10 out of 10, we have Judy Ann Milne. Well done. Followed by Sipumle, Mandile, Farida, Kosi Sochukwo. Did I butcher your name? Apologies. So that's your leaderboard. Congratulations.
Thank you so much, Andrea, and everyone for participating in the quiz. I can see many of you are really engaged and picking up the key points from the session, which is a great job. I think we can move to the next part of the session.
Okay, thank you. Yeah, so you guys actually did well because we are only going to be discussing some of the concepts that you've been answering those questions based on now and throughout the rest of the session. So I'm just going to start. Our next section is just about thinking about variables before we get into thinking about designs of quantitative research. So a variable, what is it, right? It's in the name. It's something that varies between different units and it can vary over time. So it's a factor that can differ between people or whatever else you're analyzing and which can change over time. So an individual, that could be your age, your level of educational attainment, it could be your marital status. And if we just wanted to, like some of the examples that Andrea had, what is the average age of a particular group, right? That would be descriptive in terms of what she was showing us just now. When you start talking about different variables and their relationship to each other, we're now talking about correlation, right? So how are variables related to each other? So some of the questions we had spoke about what is the relationship between this and that. That is not necessarily experimental yet. We are only looking at how they move in the same direction or whether they move in opposite directions. And an important thing to note here about variables and moving in the same direction or opposite directions, so they could be positively correlated, they could be negatively correlated. So that doesn't necessarily indicate causation, right? So just because variables change together in a particular way, either they both move in the same direction or one increases and the one declines, that does not necessarily mean causation. Can you think of an example where something clearly isn't causing the same thing, but something would be positively or negatively correlated. You can just put it in the chat for now. Okay, I'm just looking at the chat. Can you see my screen? I see someone saying we cannot see.
I
Yes,
can
I
see
can
it.
see it.
Well, we can
Just yeah, just make sure. So there are two tabs open at the top of your screen. Make sure that you're on the second tab that says Zakir Asmal's screen.
Okay. So, I mean, just put it in the chat for now. We're going to come back to questions about causation and correlation. But can you think of an example where something is positively or negatively correlated, but we know that they're not causing each other, and why we know they're not causing the difference between the two or the changes between the two? Okay, and then let's just think about the types of variables. So we can think about variables in different ways. So in an experimental design or in an experiment, we can think about variables being independent, dependent, or control variables. So the dependent variable or any independent variable is a variable that we may hypothesize when you change that variable, it has an effect on a particular variable of interest. That variable of interest, you could call an outcome variable. So that's what we'd be interested in, what changes in that variable when there's a change in the independent variable. So that would be your dependent variable. And then we also have what are called control variables. So you'd be interested in the effect of y, let's say independent variable should be the other way around conventionally. But if you have the effect of the independent variable on a dependent variable, there are other variables that may also have an effect on that variable, which need to be controlled for, right? Because you can't say, this again goes back to the correlation example. Just because they move in the same direction does not mean that there's a causative relationship, right? So you need to take into account other variables which might have an impact on that dependent variable, and those variables are what you would call then control variables. We're not going to get into regression analysis in this module, but these will clearly come together when you do that sort of analysis where you have your sort of y equals mx plus c set up. But we don't need to, we're not going to get into that in this session. And then that's in your experiment, you could classify variables that way, but you could also, without taking it to that level, just think about the form different variables take. And that would be important for when you're collecting your data or analyzing data, right? So in terms of quantitative analysis specifically, you could have explicit numeric data, which is you'd have a closed-ended or limited sort of options for that. And they could be either discrete or continuous. If it's discrete, you have a countable number, a whole number, right? 1, 2, 3, 4. Those are your options. So things that are countable. How many apples are here, right? And you're not saying 1.08 apples. You're saying 1 apple, 2 apple, 3 apple. You could have halves, I suppose, in that particular example. But when we talk about an interval, or ratio variable, we're talking about a continuous numeric variable. So that can be measured on a continuum. So you have a range, and your acceptable option or what you'd like to capture could fit anywhere in that range. Then there's a difference between an interval variable and a ratio in your continuous variable. And the main difference is between the two is that your ratio can be measured on a continuum, and 0 means that there is none of that variable. 0 means 0. So height or distance, if we're saying 0 meters, that's 0. The difference with an interval variable is something like your temperature in Celsius or Fahrenheit. 0 does not necessarily mean there's nothing, right? It's the scale of the variable. So another way to think about an interval variable is that it cannot meaningfully be multiplied or divided. So if I say, for example, with Fahrenheit, the temperature in Fahrenheit, if I double the number, it doesn't necessarily mean that the temperature is double what it was, because it has a particular scale which has 0 in it, but that 0 doesn't have the meaning of meaning nothing. Then we can also use other variables in quantitative analysis, which are not strictly numeric in the sense that it's a number, but we can code them to be numbers. So they can be categorical, and we can assign numbers and use these numbers in our quantitative analysis, and there are methods for doing that and for making sure the interpretation makes sense. But basically, you could either have nominal categories or ordinal categories. So a nominal category is something that cannot be ranked. I could ask you, what did you spend your money on in the last month, and give you 3 options. What did you spend the majority of your money on in the past month? And I could say your house, your car, groceries. I'm not making a judgment about whether any of those is better than the other. I just want to know, what did you do? And if I wanted to use that in my quantitative analysis, I could code those as 1, 2, 3, and there would be ways for me to use that in quantitative analysis. For example, I might want to know what are the determinants of someone spending most of their income on groceries. So then I could use that data in a quantitative analysis, even though it's a categorical categories data. If it's ordinal, it means that the categories have meaning. It means that 1, 2, 3, 4, 5, there's a particular reason for that. I might ask you, how strongly do you agree? Or how happy are you? There's some sort of scale to it. 1 may mean I'm not happy at all. 5 does mean I'm like over the moon. I'm the most happy I could ever be. We'll speak about questionnaire design briefly later on. With these sort of questions, or this sort of data particularly, you have to be very clear about what you mean. And if you're collecting the data, you need to be sure that everyone that you're collecting data from knows exactly what you mean. And we'll speak about reliability and validity of measures as well. But because these categories can be open to interpretation, you need to be very careful about how you collect data and how you use data and how you interpret data when you use quantitative analysis with these types of variables. I've also put string in there, although you probably wouldn't use it too much in specific quantitative analysis, but there are ways that you could. If you use a string data, which is open-ended, it's limited. I could ask you a question, and in my questionnaire, I'd let you answer that in any way you want. It could be a sentence, it could be a description. You typically wouldn't use that type of data in your quantitative analysis, but you could go back to, for example, that data you've collected and code it in a particular way and still use it in quantitative analysis. But you're now straddling the field more with not being quantitative analysis. But I mean, you can do that. You just have to be careful about that. Then when we talk about validity and reliability in measurement, so this will impact the quality of your research. So the reliability refers to how consistent your measure of something is, and validity refers to how accurate your measure of something is. If you are not having measures that are valid and reliable, that could lead to unreliable results, unvalid results. It's a bias, could be a bias in your result. So you may not particularly be measuring what you think you're measuring, or what you're measuring is fine, but the way you're measuring it comes out differently in different by different measures. So in the first case, when we talk about reliability, is the measure reproducible? Under the same conditions, will you obtain the same result? Using the same methods, will different people measuring that obtain the same result? Using the same methods, will a measurer obtain the same results at different times? And a measure can be reliable but not valid. So you could be measuring something in a reliable, consistent way, but when we talk about validity, what we're talking about is, are you actually measuring what you're supposed to measure? That's a bit circular. But for example, if I have some sort of scale where I want to measure how happy someone is, So you might do a lit review on how to do that. You might see how other people have done that. But you might not be actually measuring that. You might have a scale of questions, and the way the question is worded is interpreted in a different way by participants. They don't actually take that question to mean what you think it means. That means then your whole research question, the way you've constructed your research, the results you analyze from that research would not be valid because you're not measuring what you think you are measuring. So those type of things are very, you have to be careful about that. What is the point of your research? How are you measuring it? And how are you putting across your question? Are you collecting data which actually tells you what you're interested in? And when we speak about questionnaire design later on, we'll speak about some ways in which you can ensure that you get reliable and valid data. We're a bit early, it's about 10:20. The next section goes into the quantitative research designs. But I think I just want to, because we have discussed experimental designs, that I think I do want to just give you a better sense of that at this point. So if you could just give me 5 minutes or so, I do want to get into this because you had it in the quiz earlier. So when we talk about a non-experimental design, we talk about data that's observed and measured without manipulating variables, and this can be descriptive or correlational. But when we're talking about experimental and quasi-experimental designs, you're collecting that data or you're considering that data with the aim of examining causality. So that would involve manipulation of a variable or groups to isolate the causal effect. So the question then, you're asking something like, what happens to Y as X changes? What is the difference in Y in two similar groups when X differs between the two groups? The important thing is that you're testing a hypothesis and you're designing your experiment and collecting data to consider the effect of the dependent variable on the dependent variable. So with an experimental design, you have full control of the experiment. Typically, you'd have random assignment incorporated in the design, and you'd compare a treatment group to a control group. So I want to know, what is the effect of this medication on a participant, for example? I'd have a treatment group and a control group. One group would get the treatment, whatever I'm interested in the effect of, and the other group would not. They might get a placebo, and there's ethics to consider, and there's costs, and I mean, it's the kind of like gold standard if you want to identify a causal effect, but it's not always possible to do this type of experiment. So that's where quasi-experimental designs would come into play, where you may not have full control of an experiment. You take advantage of a circumstance that naturally occurs or manipulate existing data to obtain estimates of a causal effect. So you'd still have a comparison group, but this comparison group is not determined by random assignment. So what you want to do then is to find comparable groups that exist already or with slight manipulation. So you might, for example, have a policy change. So very often, for example, when we look at the effects of minimum wage on the labor market, sometimes there's a change in the minimum wage in two otherwise very similar areas. And then if you can justify having comparable or thinking that the groups are comparable, we'd say that that policy change, for example, these two groups have reacted the same in the labor market, over time. But when this change happened, something happened there. And then you could say, for example, that the difference in what we observe after is due to the difference in the change in the policy or minimum wage or whatever it may be. Another way to do it is to match similar individuals. Without getting too technical, you could construct a group that is exposed to what you want to know the effect of, and construct a group which is not exposed. and you'd say you think they're similar in these ways, and the only material difference is this effect. Now you can tell that this is getting very complicated, right? It's theoretically it's sound, but in an applied context, this gets very tricky. There are so many things to consider. Your result will be biased if those groups differ in a material way, right? Because I may be saying boys, the two groups I have, one might be a group of boys, one might be a group of girls. And I say, I want to compare these two groups. But there's a reason, there's a gender-based effect that is now affecting your outcome variable, right? For some reason, there's something related to your group being boys, which may impact on the result you see. So your comparison group, if it was just done by gender, might not be valid. It might not actually tell you, and it might not give you what you want to see. The outcome you're seeing might not be due to the treatment. It might be due to the varying factors, such as this was a group of boys. And you might then say, well, look, I had two groups. It's clear when I treated this group or we had this intervention, they did better. But maybe there was something about that group. Maybe boys tend to do better or worse for another reason. So those two groups are not actually comparable, and it's not a valid counterfactual. So when we talk about a counterfactual, I'm just going to get through the slide. I have 5 more minutes, just checking there. So if you think about it this way, and this is like, you could never do this, but essentially what you want to do is, if you had the two exact same groups, and you could somehow multiply that group, put it in another universe, and have a different version of that group in another universe, where they're exposed to the thing you want to measure the effect of, and the other group isn't, what would be the difference between the outcome you observe? We can't do that in the real world, right? So we try to get as close as possible, and through randomizing the sample in randomized controlled trials, I mean, that's considered to be a gold standard in doing this sort of like treatment versus control group sort of experiment. You are trying to get at that effect using comparable groups. But in both experimental and quasi-experimental designs, the key thing you need to do is to ensure that the comparison group is not different from the treatment group in any way that would result in a biased result. And theoretically, that's we can say that, but in applied, I can tell you, it's like in applied context, it comes up with a lot of well, you need to think about it very hard. It's very difficult to identify whether these groups are comparable in the way that you want it to be. You could not be accounting for a factor that biases the result, and then your result would then be biased in that way and might not be generalizable. But I think I'm going to stop there. But we have a few minutes. I don't know if we want to just take a few questions. I know that was maybe a bit too much to take in.
Thank you so much, Zakir, for that clear breakdown of variables and measurements. I think these concepts really are the foundation for designing robust research or quantitative research. I can see that the next item here is the break, the 30 minutes break, but I think we can take some few minutes, some few questions from here. People can just raise their hands and drop the questions on the chat, and then we'll take a few questions before we go to the break.
There are a few questions in the chat. Suppose it's here.
Okay, Gokanyela, can you please help me with the questions on the chat?
Yeah, so there's two actually. The first one is just more of a request to Zakir, if you could kind of share a bit more light on, I'm guessing, the difference between the experimental and quasi-experimental design. And yeah, so I think both these questions are just asking
Okay.
about the experimental and quasi-design. Yeah, thanks.
Okay. Okay, so experimental is, I think the key difference is that you are in control of the experiment, right? So from the outset, you have the resources, you have the time, you are able to administer different treatments to two different groups, and you have full control of that experiment. You've designed it from the start, you're administering it. You've thought about what your goal is, what the aim of your research is, and you've gone back and designed the experiment so that you get the data that you need to assess that effect that you're interested in. With the quasi-experimental design, you typically would either be constrained in the fact that you either cannot collect the data yourself for whatever reason. There might be ethical concerns with collecting the data. There might be budgetary reasons why you cannot do that yourself. And this happens, sometimes it's just not possible. And so particularly in, I think, economics, what often happens is that we make use of existing data or look for natural experiments, in the sense that something changed and we can use that to now identify a causal effect. So we didn't go to collect the data ourselves, but we've identified some circumstance in the world or some data set which can manipulate it in a way which we can artificially sort of construct those comparison groups. So in both cases, you have a comparison group, but in the one case, you constructing the comparison group yourself, you're able to do it. You have no limitations in doing that. And you will be able to identify the effect in line with the experiment you designed. The quasi-experimental is not, so the ideal thing, what you'd ideally want to do is do an experimental design, but in the real world, it's not possible for many reasons sometimes, and it's depending on what effect you're interested in. So when you're talking about quasi-experimental design, you have to be a bit creative and think about, how can I identify this effect without having collected this data myself, without having administered this treatment effect myself or intervention myself. I don't know if that helps, but
yeah.
we will
Sorry,
come
sir,
back.
can I just
Yes, you
add
can
a
come
bit
in.
on thank you. The main difference and the main reason why we end up going for quasi-experimental instead of experimental is that we, especially as we are in the social sciences, and for us to have a complete 100% experimental design, it means we randomly select people into a program, right? But like Zakir had said, it has ethical problems. For example, remember the days of HIV, AIDS. Would we, to have an actual before and after effect of the difference between the selection group and the control group, it means people had to be randomly selected into for ARVs as an example. But can we really select people and leave the others to use them as a control when there are people who are sick and who need an intervention, for the sake of being able to compare the people who were given ARVs and those who were not? So because of those ethical reasons, most of the time in social sciences, it's very difficult for us to have a full experimental. Therefore, we move to quasi-experimental, usually by taking people that are already in the intervention. We randomly select them still, but they're already in the intervention, and those that were not in the intervention. A good example is when we use threshold for things like social grants, because it is a cut-off figure. Maybe if you are household income is this much, or in my area in food security, people who receive food aid, if your income maybe is up to, let's say, $100 per month, you go into the program. If it's from 101 above, you don't go. That's the design of the program. But we can compare. Usually someone whose household income is 101 and that one who doesn't go, and that one with 100, they are not different. So that's now the people that we use as the control group, because they were already not included in the program. So it's basically because we deal with people, and it's almost impossible to have a full experiment like in the natural sciences. Thanks.
Zakir, I just put up a quick diagram that may help people understand. It just summarizes everything that you've said.
Okay, thank you. I don't know, so I may be generalizing, but maybe you can also weigh in. I think it's very unlikely, especially unless you're in a particular field, that we would be doing a full experimental design. Especially like for the reasons Vandutsa has also noted, we're more likely to take a quasi-experimental approach in the social sciences. But it's useful to understand the experimental design, because that is kind of like what you're trying to replicate on some level, but you're unable to do for these various reasons.
All right. Thank you so much, Zakir. I don't see any questions now from the chat. And yeah, I just want to thank you, the previous presenters, for their insightful presentations. It was very informative and thought-provoking. And I want to thank everyone for their great engagement and participation so far. The time now is 10:36 from my side, and now we're supposed to take a break for 30 minutes. But I would like us to go to the break and request that we come back at 11. Is that okay with everyone?
Yes, it's okay. Thank you.
That's
It's
okay.
okay, thank you.
All right. Thank you, everyone. I'll see you at 11.
Please stay in the session. Don't drop off.
But have you actually captured the population group that you're after? And so thinking about this representativity is really key. Next one. So this figure over here gives us a sense of the basics. So if we've got this theoretical population out there, okay, let's just pretend that that's everybody in the whole country. We've got a very small country. You can see that we've got these different sorts of groups. And if I didn't have 250 people in the room, and if you were face to face, I could sort of ask you to identify, these different characteristics. You can see there's differences by gender. We have male and female. We've got differences in ethnicity. We've got different race groups represented there. And then other sorts of differences between, I don't know, hair color, hair type, and all these different people, you can have other associations too, in terms of wage levels or occupations or et cetera, et cetera. But let's just pretend that all the features of this population that we're kind of interested in are represented visually by what we can see here. And let's say that we go to this population and we want to draw a sample of 10 people to represent the whole group. And we go and we pick our sample in sample A, and we pick, all these dudes and the ladies in the blue. If you can see, my mouse probably isn't showing, it's not my screen, but it's sample A down there. And the question is it representative? And of course, The answer is no, it's not representative. Why? Well, look at all the groups that we haven't met. We've got no one in this who's sort of brown skinned. We've got no one with blonde hair. You know, you can quite clearly see where we're missing sorts of characteristics. So sample A, even though it's 10, not good enough. What about sample B? Let's have a look at sample B. Well, it says the answer that it's unrepresentative, so no reward for getting right that it's also not good enough. But why is it not good enough? Who we're missing in sample B? And a quick squiz shows that we are missing. Got that guy? Got that cherry? Got that? We got that. We're missing this group over here. Oh, sorry, my mouse isn't working. So, damn. We're missing the guy in the purple shirt and blonde hair on the fourth year. That's what we're missing. And you see he's not represented. No one from his category is represented. And then sample C. Well, if you just count it out, we've got 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. You can see that of these, 50 people, we need to sort of take one from each to make a representative sample. Okay, I think I've said, you get the point. So when we sample, it's really important that we have representativity from all the different groups. Right, next slide. So that brings us to another aspect of sampling, and that is that even though you want a random sample of everybody, often when you go into the field and when our official statistics agencies go into the field, so I'm talking from a South African perspective, it would be Stats SA, but we know there are other people in the room, maybe it's from Kenya or Zambia or your official statistic organization. When they go into the field, they never get it right. They try and randomly sample, but there are people who don't respond. Any number of reasons which stops the sample from being random. So often you need to also apply a weight onto a sample. And what the weight does is it recognizes that a certain group might be underrepresented. So typically in the South African context, you have white rich people who don't want to engage with the survey respondents. And therefore, you have an underrepresentation of white people. So what can you do? Well, what you can do is go to the sample itself. And if you've got 5% of your sample being white and you actually need 10%, you apply a weight to it, which means that every white person sampled actually counts for 2, not for 1. And that doubles the weights. And you can calibrate your weights along a range of different characteristics to sort of match it up to what should be representative for the population. So the sample calibration, which they do to make these weights, often includes age and gender and race. Those are kind of the main key ones. But of course, the more variables you add for your calibration, hopefully the better it gets. But my main point here is that if you don't understand this concept of weighting, when you work with your secondary data, often you actually won't be producing representative statistics. So this is a key concept that you need to take this additional step in your descriptive and all your other data analysis to weight the population so that what you say is authoritative about the national population. Otherwise, if you just take the number of people that are randomly sampled, often it's not randomly sampled. And this is the advantage of secondary data, is that Stats SA or your official organizations will have done the hard work to calibrate your sample and get it ready so that you can weight it and say things that are authoritative about the population. Having said that, just because you've ticked the boxes about weights and you've ticked the boxes about just because you've ticked the boxes doesn't mean that it's actually worked out in practice. There can still be reasons to be suspicious of data. So the more you work with data, you can't just take it as fact, guys. We need to look at the data carefully, interrogate it, and think carefully whether or not we believe it. Certain questions can be more sensitive than other. Income, for instance, is notoriously difficult to collect, but just depending on the issue that you're exploring, some issues are kind of, you've got no reason to believe why people wouldn't be forthcoming, but others, there can be bias. And so there are many reasons why bias can be introduced. And if we're aware of it, hopefully when we do our analysis, etc., we can, do things to sort of, at least, in the very least, we can at least warn the reader that that there could be limitations here or there. Okay, let's carry on going. Okay, I see a question, and sorry, I can't follow the questions and do the lecturing, so I'm hoping my colleagues will be typing, but I see a good one. The person says, it's Siva, if you apply weights to treat the white race, does it affect the other races in the sample? So, as I said, what generally happens is that there will be a population benchmark in terms of your proportions, and your weights will then try and look at who you've got, and where you're underrepresented, give those people more weight. And sometimes where you're overrepresented, you can give less weight. So yeah, the weight that gets generated is one weight for the whole sample. And in some ways, what it does is it sort of like recalibrates it such that that when you apply the weight, it's now representative of what's happening at the population level. In practice, I just know from experience that whites are historically underrepresented, but in every population group, we could be doing, you could be doing a study in Vietnam or in China or whatever, and each population group will have their own sorts of nuances. But what I'm saying is that the secondary data that you get given by an official statistic often will come with a weight. Please use it. Otherwise, generally your representativity isn't the best. I mean, can you produce statistics without weights? Of course you can. Maybe it's better than nothing, but yeah, best case scenario is you have weights and you apply the weights and you use it. So in your secondary data module, I really hope that they show you practically in your statistical tool how to apply the weights. So if you're using Stata or SPSS, that doesn't really matter. The point is that you apply the weight when you generate the statistic. Okay, cool. And changing the results, changing the weights changes the results. I actually took a slide out for you where a group that are very interested in this called Data First show a range of different weights you can apply to South African data. And you can see that you get quite big differences in proportions when you change the weights. I mean, it makes sense. If you've got a population and it doesn't have a lot of white people in it and it's undersampled and you pretend as if that's random, then when you say, you take a variable like income and you say, this is the average income for my population, and you're missing a lot of white rich people, then of course the average income seems to be lower than what it really is. So yeah, or if you're missing young people, because young people tend to be, working during the day and not accessible in some context, and then you find that actually you don't have those young people and it can affect what you're trying to study. So yeah, it really does matter. Okay, I think the next little bit is talking a little bit about understanding why and how statistics work. And I'm going to do my best to make this intuitive, but it really matters and it's very exciting. This is what you find with heights, okay? And what we've got here is a sample of women and a sample of men. And we can pick, let's pretend our sample is like 1,000. And so we've got 500 women, 500 men. What we could do is along the x-axis, we could look at how high or how short or how tall different people are. And then we could sort of, along the y-axis, look at how many people fall in these different categories. And so the bell shape is showing you the higher upper it is, it means the more people fall in each of these sort of height bands that we create. This is what is known as a sort of histogram. And of course, if you've got lots of very small bins, it sort of moves into the sort of density plot that you can see over here. The point is that if you pick one person from your population, they could be very short or they could be very, very tall. And if you pick one woman, that woman could be a tall woman, and you could pick one guy, he could be a short guy. If you've only got those two people, it's of course ludicrous then to say, oh, well, in this population, all the women are taller than the men. What's the problem? Well, you've only taken like one person here and one person there. The point is that when you take a lot of people together and you have more and more, it averages itself out. And the bell curve or the normal distribution is, for, in most cases, the way in which statistics behave. And that is that around the average, you have the most people at that average point. The average we often call, in statistical terms, the mean. Okay. Then you have people who fall below the average, and the further away you fall from the average, the less likely. So yes, you do get very, very short people, but the number of them is small. Whereas those who are just a little bit short, less far away from the average, there's a lot of them still, but the highest concentration is at the average. And that's what causes this sort of bell distribution with low proportions at extreme values, either very low proportions, extreme values, either very, very short or very, very tall. You have the most extreme and therefore the less likely. Is it possible? You'll be surprised in the world. They're always possible, right? Always very, very tall and very, very short. But of course, can you get someone who's 5 meters tall? No. So there's always a limit to the kind of distribution of the sample. Those are called outliers at the very extremes. And sometimes in statistics, we want to look at those outliers and even axe them from our sample, but I'm getting distracted. Okay, so we've got this distribution. If we go and we don't just take one, but we take 500 men and 500 women, this is what we generally find. And if we then measure the average height for the woman in our 500 sample and the average height for men in our 500 sample, this is what you would find, that the men's height would be 178.4 centimeters and the female height would be 164.7 meters. And that would then be the difference in height across this different distribution. If the distribution is normal, like was what you call this word for this looking bell curve, it means that whether you look at the left or you look at the right, if you're shorter or you're taller, it behaves in exactly the same way. And what that means is that the middle, if you line everyone up in a row and you go to the middle of that row, that will be at the same point as the average. So the average person and the middle person, or what we call median in statistics, will be in the same position. Now, there's another statistical term it's important to understand, and that is the sense of how this distribution functions around the mean and the median, and that's called your standard deviation. And what we find is that if you have one standard deviation to the left and one standard deviation to the right, you get 68% of everybody. So if you're just one, measure to the left and one measure to the right, you capture 68. If you go 2 standard deviations to the left and 2 standard deviations to the right, you end up getting 95% of everybody. And if you go 3 standard deviations, you get 99% of everybody. So just kind of give that standard deviation gives you a sense of how easy it, or how much of the sample gets captured. And so one standard deviation is kind of, you're getting like pretty much 2/3. So 68%, so 2/3 would be 66, but in statistical terms the standard deviation is 68. That's kind of the sense of it. So it's most people, but 2 standard deviations gets you almost everyone. It will cover 95%, and 3 standard deviations is like 99%. Okay, why this all matters, and let's go to the next slide, is that we've been talking about a sample of people and heights. But another thing for us to be thinking about is a sample of samples. What do I mean by this? You are going to go into the field with your survey instrument and collect from a whole bunch of people. And let's say you're collecting the heights. And let's stick with the example of 500 men and 500 women that you collect your heights of. You go into the field and you collect all their heights, and then you calculate the average, and you get an average for men, and you get an average for women, and you get an average for the population. And let's say the average for, let's stick with the population to make it easy, so we just ignore men and women, let's just go for everybody. In my sample that I went to the field, I have an average height for everyone of 168 centimeters from my sample. Yay, that tells me that I think in the population out there that the average height is 168 centimeters. If you now go into the field again on another day and you again collect responses of 500 men, 500 women, 1,000 people, what are the chances that you're still going to get the average at being 168 centimeters? It's a very good question. And in reality, there'll always be some amount of difference, because every time you go and you collect your 1,000, maybe sometimes you get a little bit shorter, sometimes you get a little bit taller. But what you will find is that it'll be very close to the real population average height. If I somehow knew what that average height, let's say it's 168.5 centimeters. If I get one sample that's 168, another sample that's 169, another one that's 168.7, you can see that I kind of expect my sample to behave in a way in which it's giving me a good close to the average. Therefore my sample will be the same as my average for my population. And this is the essence of us doing statistics with our different samples. And just in the same way that I said that there was a normal distribution of heights for my sample of 500 people, what we expect is that if we collected many different samples and we lined them up in a row, that those samples themselves would also have a normal distribution. So 68% of the time, you would have it between one standard deviation, and then every now and then you could get a sample that's actually pretty extreme, lying in the extremes. But most of the time, the sample that you get will be very representative of the population. And the big thing to realize is that the more people you have in your sample, the closer your approximation is to your population group. So it makes sense, right? If I have a very small sample of only 10 people, what are my chances of that average height of that 10 people matching the average height of the 60, what are we on South Africa now? Million odd people in South Africa. If I just pick 10, not so good, right? But if I have a sample of 100,000, the average of that 100,000 people I've got is going to be much more likely to be very close to the population. And as I get bigger and bigger with my sample, the more likely it's going to be representative of the population. So in basic terms, your sample matters because if it's too small, you can't measure it accurately. But if it's very big, then you get more and more confidence with it. And what we can do, and there's this magical formula from the normal curve distribution that allows us to actually put an estimate to our sample as to how confident we are that the statistic we see from our sample will match the statistic that we see in the population. Now, this is all hypothetical. We don't actually know what the population true value is. If we knew the population true value, then why would we be doing the statistic in the first place? But because of the nature of collecting statistics and the normal curve, we can use a particular formula to also expect our sample that we pick to behave in a similar way. And so based on that formula, what it can spit out for us is a measure of confidence of how close we think that sample is to the population. And that's what we call the standard error. So in statistics, we talk about means, we talk about medians, that's the middle of the distribution. We talk about standard deviations, which is in our sample population, how it varies. But the standard error is a specific term that we give to say that actually this sample itself, when we calculate a statistic for it, how accurate is that sample of what we're trying to measure out there in the population? And all the statistical programs that you will use in your secondary data analysis will spit out the standard error for you. Okay, now I'm moving into the those are all theoretical. This is kind of what you need to know. So if you didn't follow me, I'm sorry, I tried my best, but this is what you need to know.
Justin, could you just say a little bit on stratified sampling as a way of having not to weight data? And there was another question about the tools of weighting in qualitative, I think that means quantitative analysis. Something about what a weight looks like. So, what a weighting factor looks like. And then the second one is just, Querida asked about not needing weight. So I was thinking stratified sampling as well.
I'll try my best to respond. I mean, I'm not a statistician, but I think I can respond to those. Okay, what does the weight look like in reality? So let's say we're working with the General Household Survey for South Africa. Its sample is around, I think, 60,000 people, might be 40,000, it's somewhere around there. It's quite a big number. That weight will be a number, and generally that number will, when you add that number up across everybody, it will then add up to the whole population. So let's say the population was purely random, okay, of the 60,000, and let's just pretend South Africa's population is 60 million, then it would be a number like, I can't do it offhand. What do you times 60,000 by to get to 60 million? 100, 1,000, you know, you times it by 1,000. So your weight will be roughly about 1,000, and it'll vary because some people will apply more weight and some people will apply less weight. But when you apply that weight, it kind of scales everybody up to what they would represent. So this person doesn't just represent themselves, but they're representing 1,000 other people who we didn't manage to sample. That's kind of how the weights then fit together. But of course, more underrepresentative groups, we will skew more, and overrepresentative, we skew less. But the totals will then still all total up to that population number or value. That's kind of the essence of how that weight works out in practice. So it's just one number that you find in your survey that you download. And I do have a bonus slide as to finding secondary data, which I'll share with you at the end of the section. But in those surveys, you'll find it'll be called weight, or just search for weight, and you'll see that there will be a weight variable in there. And often in the metadata, it'll explain what exactly they did, but it's just a number that ranges, and depending on if it's big or small, just depends on how they calibrated it. But they do all the fancy footwork for you. That's the advantage of working with secondary data. Stratified sampling, my understanding is that, you know, when you go into the field itself, if you want to target, you know, certain dimensions, age, race, gender, that you make sure that you find people that match those proportions to start off with, and then you've got a higher chance of matching what you want. In reality, even if you do stratify, you generally might still need a weight, because, you know, you still might find that you're under or over sample. So I think whether you stratify or don't, my understanding is that those weights will still matter. In practice, I've never seen a Statistics South Africa survey that doesn't need weights, other than the census, which is supposed to theoretically be for the population. But anyway, South Africa's census 2022, I don't want to digress. Okay. This is not really the point of going into some of those details about sampling and weights is just so that you understand the importance of it and why we do it. In reality, you have software that does all the hard lifting for you. One of the things that it spits out and will make your research much more robust and much more believable, and if I as an economist am looking at what you're doing, this is what I'm looking for. I want to know that you're not just reporting the number, the statistic, that you're also reporting for me the standard error. Remember, that standard error gives me a sense of how good your sample does of representing the population. And sometimes, you know, it doesn't do such a good job. And actually, there's a lot of variation in what that sample could be in terms of representing the population. What do I mean by that in practical terms? We talk about the standard error, but the easiest thing to understand is if we just report a direct confidence interval. Now, a 95% confidence interval is shown in this table here. This is just descriptive statistics. It's a cohort. It's of different migrant groups. You've got people who've remained rural in every wave here. You've got people who moved from a rural to an urban area, and then you've got people who only were in an urban area. And if we just look at their statistics in wave one of these three different groups, we can look at their age. And what do we see? The average age of people who remain rural over the 5 waves, when we look at their age in wave one, is 36 years. For those who move from a rural to an urban area, it's 27 years. So that's about 10 years difference. Looks significant, doesn't it? And those who remained urban, it's 36.1 years. Now, the question is 27 really lower than the 36? Or is it just because I happen to pick people in the sample and those people in the sample just happen to be lower? The good news is that the standard error tells you how good your sample is doing. Now, the standard error can be used to create this 95% confidence interval, and I've put it in brackets underneath. So if we look at remained rural, it tells us that 95%, with 95% confidence, the sample that I've got would calculate an average age of between 35.6 years and 36.8 years. So if I'd just happened to have gone into the field in a different day, I might not have got this 36.2 years for my remained rural category. I could have got it a bit lower, but I'm not going to get it as low as 27. 95% of the time, a different sample than I've got into the field would have got me anywhere between 35.6 years and a high of 36.8. In other words, yes, averages across the samples could be different, but they're not likely to be very different. They're going to be somewhere between 35 and 36. So that's the real population estimate. In my sample, the average age is 36.2. But in another sample, if I just happened to go in another day, this is telling me that it would probably be somewhere between 35.6 years and 36.8 years. And this is important because when I look at my rural to urban group and it's 27 years, I can do the same. I can look at the 95% confidence interval, and it says that 95% of the time, this sample would have been somewhere between 26 years and 28 years. 26 and 28 is very different from between 35 and 36. So these two confidence intervals don't overlap in any way. They are different. And so I can say, and this is the word we use in quantitative methods, I can say that this result is statistically, let me put it clearer. My rural to urban group are younger than my remained rural group. This is statistically significant with a 95% level of confidence. Okay. So it's a whole lot of fancy statistical lingo, but why it matters is that there are many cases where actually the confidence band is really wide. So let's look at comparing the remained rural group with the remained urban group and the average age. Yes, 36.2 for remained rural is different from 36.1 for remained urban. They are different numbers, but are they different? Are they statistically significant? Could it just be sample error? The fact that I go in a different day and my sample spits out a slightly different number. Well, I expect my sample with 95% confidence to spit out a number of 35.6 to 36.8 for remained rural, and for remained urban, 35.2 and 36.9. Can you see that they completely overlap those confidence intervals? In other words, actually, there's no difference statistically between those two different numbers because the confidence intervals are kind of overlapping from one another. So that's why when you produce statistics, what you can do is also report your standard error or transform that standard error into something that's more easy to interpret, which is generally your confidence bands. And your statistical programs let you pick those. For the record, your standard error, you just times by 2 and add to the left and to the right to change it to actually work out the confidence band. But as I say, it's more important that you sort of get an intuitive sense of these things because your statistical programs do it automatically for you. As long as you apply the weight, you tell it to generate the standard error, it will tell you how precise your sample is for your population. And often it doesn't matter. It's a very narrow band, that 95% confidence. But sometimes actually that confidence is really wide, and if that band's really wide, it tells you you're not measuring it very accurately. Whew. I really hope that you got that. Let's move on. So this is showing you visually, it is showing you, I think these are unemployment rates in South Africa as reported in the quarterly labor force survey in 2008, 2009, 2010. You can see it goes on to 2014. And this is showing you the percentage of your adult population who report being unemployed. And what you notice is that it goes up in 2008 from a number of about 28.7, and it jumps up in 2009 to a number of about 33.5. That jump is a big jump. How do I know whether it's a real change or is it just a sample that I happen to pick? Because I've also included the 95% confidence interval, I've done it as bars, so you can just see how big the bars are. You can see that those bars don't overlap in any way. That's a statistically significant difference. It jumps up. When I go from 2009 to 2010, it jumps up again. And in this instance, it's still statistically significant, even though it's now getting a little bit touch and go. Those bars are kind of quite close to one another. But when I go from 2010 to 2011, in reality, my sample, my unemployment rate's going from 35.1 to about 34.9. It is going down, but just a little bit. But because it's going down by so little, actually, it could just be the fact that I picked a particular sample on that day. The confidence intervals, you can see, could measure it anywhere within that band. And so that's telling me that actually I shouldn't be telling the public or telling my examiner that unemployment went down because it's not statistically significant. In statistical terms, could have gone down, could have gone up, pretty much the same. That's all that we can say. A last thing to say, which I hope doesn't confuse you all, is that even though I've spoken about it in rough terms about these confidence intervals overlapping or not, in reality, your confidence intervals can overlap a little bit and it can still be statistically significant. The rule of thumb is that it mustn't overlap. The bottom bar and the top bar mustn't overlap by more than 0.6. But you know, if they don't overlap, you know for 100% certain that it's statistically significant. You can test each of your estimates by using a t-test and applying some other methods to just make apply a specific test to test the difference between two statistics. But generally, it's sort of time consuming. When you produce your descriptive statistics, include your standard errors, include your 95% confidence intervals, and you can very quickly see how accurately things are being measured, and you can very quickly see if things are overlapping or not. And if they don't overlap, you know for 100% certain that there's a statistically significant change. If they do overlap, you need to look carefully, because if they just overlap a tiny bit, it's still statistically significant, the difference. It's where they overlap by the bottom and the half bar by just kind of over halfway that it starts to move into that territory where your test would be rejected. Okay, don't worry if you got confused by that. For another day. Cool. So I've got one more bonus slide. Super C, do I have time to give a bonus slide?
Yes, you can. You can continue, Zakir.
Okay. I need to share my screen to do this. Can I do that? I've sent a request to share my screen.
Hey, I'll stop sharing and I think you'll be able to.
Okay, here we go. Right. So like I said, the cool thing about secondary data is that someone's done the hard work for you. The question is, where do you get this data? Well, there is a brilliant portal for data across the African continent. It's called Data First. So I'm just going to type in my Google, Data First. Sorry, I wanted to search right data. You are seeing my browser. Just shout if you're not. Data First. Okay. And I've done a Google search. I put Data First, and you can see there the UCT logo. And this is the website, datafirst.uct.ac.za. I click on the home page. I want to get data, and I want to look at open data, right? And it says visit our open data portal. Oh, sorry. Let me click visit. And boom, here it is. And we've got 562 surveys on the continent for me to explore. And so what is my research question? I'm interested in informal settlements. So what can I find? Let me have a look. Let me think. What keyword could I look for? Or maybe I'll just look for the word settlement. Oops, and see what pops out. Community survey, 2007. Community level social dynamic survey. You can see it's originally a whole lot of surveys where this word settlement is popping out. Okay, so you can kind of like play around, try and find something. But often you might know of a particular survey that you're interested in, and you could kind of look for it directly, looking for years or looking at countries. The point is that all of this is organized really nicely on this portal. Let's have a look at the community survey 2007 is quite old. There'll be an updated one. Let's look at the general household survey. I'll put general in. Afraid this keyword search is not so good. I don't think it does any better job if I go general. Maybe I must select by country. I've got 440 database with that. It's not really limiting it very much. What else could I do to filter it? Maybe Statistics South Africa. Let me select that. Now I'm getting close. I can see the community survey 2016. Whole lot of relevant surveys, general information, tourism. You can see lots to explore. Let me just pick for now this 2016 community survey. And you can see what's nice about the Data First portal, and the reason I'm sort of bothering with going through there. Why not go directly to StatsSA? Of course, you can go directly to StatsSA, but the point is that they've curated it and organized it so that it's all, you've got everything you need. And here you can see it's giving me the study description. It's telling me the scope of who's being asked, you know, what's the population that they're trying to target. It's telling me that how, like, that I can push the data down to a local municipality level, which is really cool. It's telling me exactly how they did the sampling. It's telling me how they did the weighting. Are you with me? They've organized it all here so that you can kind of get the key dimensions. And they will have here's data descriptions. And what's really important is that, you know, downloads, let's have a look here, is that you can download the original questionnaire. I think that's normally the place to start. You can actually read through and see what questions were asked, and then it helps you when you go back into your database to sort of have a look. Here are some reports that people produced with it. And here's the metadata document, which is really important to read. And there's even a technical report. Okay, and then you click Get Microdata. Okay, it wants me to log in and register, but just to say that it's open access, there's no like paywall or anything. You just register. I think they ask you to provide a short description about what you intend to do, and it provides you instant access. You can download all the raw data. Often they have files in Stata. They also have it in SPSS. They have it in different formats. So they've done all this hard work to essentially catalog exactly the survey data, etc., that you're looking for. So I hope that at the end of this session today, that you go back to the Data First portal and you can start poking around to say what your research question is and what data already has been weighted and curated so that you can analyze it to produce your statistics. Cool. I hope that's a useful tip. I'll put a link to Data First portal. Thanks.
All
Back
right.
to you.
Thank you so much, Prof. I can see that we have less than hour and a half before the session ends. And I don't think we can take any questions from here. However, participants can put their questions on the chat and the colleagues will respond to their questions. I just want us to have a bit of time to do the group activity on the breakaway session, and also to give enough time for the next presenters to do their presentation. I see now that the next item is the breakaway session, which will be led by Zakir. Over to you,
Okay,
Zakir.
thank you. Okay, we did have quite a few slides to get through. I'll try to be as brief as possible, but you will have access to all the slides. I mean, isn't anything very
Zakir?
technical, and yeah.
Can I just suggest maybe we don't rush through the slides? We can always have the breakaway activity as a take-home assignment. I do think people would value just going through
Okay.
the fundamentals.
Or maybe we'll reduce the time for the breakaway session. I think it would be nice to just
Okay.
apply some of the things we've been considering.
Sure.
But okay, I'm not going to rush, but yeah, I'll be as brief as possible. Okay, so now that Justin has told us about the secondary data, I just want to go through some points related to collecting your own data. And the first thing I want to just share with you is primary data collection tools that you can use. So there are a lot of online data collection apps which provide new research possibilities, and they become more secure and reliable over time. They're efficient and dependable, even sometimes in offline applications, and they allow you to input your data and get your data ready to use in a form that you can analyze. And they also allow you to get a good sense of your data as soon as you've collected it, like how it's shaping up. There's some issues to consider with, and I suppose it's not just online data collection, but all data collection. You'll always have to think about the ethical considerations. But these are easy to find, they're accessible and reusable. I'm not going to go through all of them. So this slide lists many different tools that you can use. I thought I'd just spend some time very quickly to show you one in particular that we've used at the HSRC. And that is REDCap. And REDCap is a data management tool used primarily for research and quality improvement studies. It's a web-based application and it can be used from anywhere, from any encrypted mobile device. And it's been developed and deployed by Vanderbilt University, and it's actually free to use for academic purposes. So you would not be able to use it for anything that's commercial, but if it's for your research, you would be able to use it. If it's for your master's, your PhD, anything within an academic context. So I'm not going to go into this in too much detail, but what I did want to show you is that thinking about your data and how your variables look and all those sort of things are important when you design surveys using these sort of online tools. So this is just like a part showing you how to put together a survey in REDCap. And you'll see each question takes on a field, and you can choose the field type and how you'd like to present it to a participant. You can name your variables. You can choose the options that the participant will be able to choose. And I think the important thing here is to think about your data and in which form you would like to analyze it before you actually go and collect your data. So it's good to know upfront exactly what my research aim is, what I'm collecting this data for, how am I going to use it in the analysis, and then to ensure when you're putting together your survey, this isn't necessarily just for online, but I mean generally, how would that data be collected? How am I going to limit it? How am I going to make sure I get the data I want? So you don't want to like just have options for the sake of having options. You know, you need to be like, it needs to be quite tight in terms of the data you collect and who you collect it from. You don't want to overburden survey participants, and you also don't want to overburden yourself when you're doing the analysis. So you're like in the middle, but you need to consider how to balance these concerns, right? How do I collect the data that I need, but also how do I make sure I collect it in the most effective and efficient way? And then these are different types of fields that you could, it would vary from program to program, but the principles, the types would be more or less the same. Do you want them to enter data in the form of text? Is it a yes, no, true, false? And you know, you can code all those options immediately as you put together the survey online. Then something that's quite useful with these as well is that you can validate your data. So you can make sure you only receive data in a form that's usable. If you want a cell phone number, for example, and you don't want someone to just fill in 1, 2, 3, 4, 5, which is obviously not a cell phone number, you can restrict your fields in ways that you can check that the data you're getting is what you actually want it to be. So in this example, what is your contact number? It's been restricted using a South African code. And in your question, you'd have to be clear to say, please enter your cell phone number in the particular format. And then you'd only allow them to enter numbers in that format. Or, I mean, this could be, one thing is also you could be collecting data and use this as a tool to put in the data yourself, or it could be self-administered, right? And REDCap and many of these tools would allow you to do that either way. So even if the participant is not inputting the data themselves, they're not expected to do that. You, as the person collecting the data, can use these validation forms and these things to make sure that the data that you collect is also in the format that's required. I just wanted to also illustrate that when you use a tool like RedCap, I'm not sure if it will be applicable to all online tools, but what's nice about it is also that once you've set up your instrument, you can get a code book generated pretty much automatically, knowing which options to choose. And so this code book shows you each question. It shows you what options are allowed, what all the criteria are. And so when you're analyzing the data, you can always go back to this and you don't have to put it together from scratch. Because when you've actually constructed that questionnaire and you've thought about how you want your question to read and how you want the data to be inputted, it's already captured, and then you can automatically generate this. And so if you're the person collecting the data and someone else is analyzing the data, this is also useful so that they can get a sense of the data that was collected. Then you can also generate your questionnaire. So there are two different options. So what you would typically have is a form which either you send directly to the participant to fill out with instructions that are very clear, or you would have an enumerator who would use the online form while speaking to the participant, for example. And you could print out these as well if for some reason you do a combination of online capture and offline capture. So you can easily get the questionnaire in a form that can be used for on-the-ground sort of data collection as well. Obviously, the second that option would require you to then input the data, which would be your traditional sort of like data collection. But everything would be captured in the format that's consistent across both your online and if you did require to have underground data collection as well. This is an example as well as how questions could show up. You could have a matrix of different, so you might have a core question and then different statements that you want to ask the participant, and then they can fill that out in that way. And a really nice thing about this as well is that you can export the data in a way that's...
Zakir?
Yeah.
Yes, I'm looking at the time. Can we please try and wrap up by 12?
This is the last,
Okay, all
this
right.
is the
Thank you
last
so much.
slide on this.
Thank you.
So I just want to emphasize that you can, whatever you know you'll be analyzing your data in, you can directly export your data in that format. So it's pretty much ready to go and work with. The most important thing is to think about how you structure your questionnaire, how you get the data that you want. If you do that properly, then this would be like smooth sailing to the point where you actually get to your data analysis. The exercise that we'll be doing, and we've got now 5 minutes before we should ideally get into the breakaway session, is about thinking about designing your own questionnaire. And some of the things that you need to consider in doing that is, what is the aim of your questionnaire? What are the question styles you'd like to use? How do you design the questions in terms of the way you word them? How do you structure the questionnaire? So which questions should come where in the questionnaire? Is there a logical flow? Is there a flow which would put the participant at ease or make sense to the participant? Are there questions, for example, you ask upfront that puts the participant off and might jeopardize you completing the questionnaire? Very important is piloting the questionnaire, because no matter how much lit review you do, no matter whether you've looked at other questionnaires, you need to know how that questionnaire is going to play out in your specific context. And so you will typically need to refine that questionnaire depending on testing the instrument. And then you revise it, and then you would only go to administer the final questionnaire. And you don't have to reinvent the wheel, right? So if there are specific concepts that other people have measured, if it's been measured consistently in the literature in a particular way, you can approach your own questionnaire that way. You administer the survey. So if it's on the phone, they're going to self-administer it. If it's on the ground, that will affect also how you think about your survey or questionnaire. Who are you speaking to? Like, how should you phrase the questions for the particular group that you'd like to collect data from? it's important to keep it as short as possible, but I mean, it's very difficult sometimes because you want to collect all this data. That's why, it's important to think about it upfront. What is absolutely necessary and how do I collect that in the most painless way for both you collecting the data and the person who is will be required to give you that data. So make use of filtering and branching. So what is the logic? If you ask particular questions which tell you that a specific section of your questionnaire would not be appropriate for that person, you don't need to ask that person a question, and that should be built in to the way your questionnaire is structured. You can have open-ended and close-ended questions, but just bear in mind that respondents are more likely to skip open-ended questions and questions that are too wordy or not to the point. You could have rating scales. It's very important that those should be unambiguous. 5 to 7 point scales are typically used. That would be when you're asking about levels of agreement, satisfaction, that sort of thing. And in your categorical questions, also think about the order in which you present options. Is there any way that they may be biased towards the first option the year, the last option the year, the middle option? I mean, those are the type of things that do happen. So just quickly, the ideal question then accomplishes 3 goals. It measures the underlying concept it's intended to. It doesn't measure any other concepts, and it means the same thing to all respondents. These are just general points. I think it's repetition. We have covered this. I'll come back to them after the questionnaire exercise. But to get into the breakaway session, I think we'll make it by 12 o'clock. What I would like us to do is break into groups and agree on a research question.
Sorry, Sakir, do we still have time for breakaway sessions? Because my slot is for 45 minutes, then 10 minutes for Andrea, and then 15 minutes for the last Q&A and the closing. That's more than 1 hour already.
Okay. Maybe if I can
but
just
we're
ask you.
just having an hour to go.
Do you think you will use 45 minutes, Van did say?
I can't use 45 minutes anymore, even if you were done.
Okay.
So
Okay,
I think
so
it's important to
I think
that we move
we'll
to the
share
next.
this. Let's move on to the next section. Yeah, okay. Let's go through everything. If we do have time, let's come back. Does that work? I don't think we will, but yeah. Okay. So let's move on to the next section. I'll move the slides for you, Van did say. Sorry.
Over to you, Van der Zai.
Thank you, Busi. Okay, it's still good morning, colleagues. Okay, I'm not sure if my video is showing. I can't see anything.
We can see you.
Okay, thanks. Okay, yeah, once again, my name is Van der Zai, and may we please go to the first slide for me, Sakir? Okay, thanks. Okay, I'm going to take the discussion back to very simple things. Prof. Justin and Sakir were going more technical as we move towards wrapping up the session. Some of the things have already been mentioned, so it's more like a wrap up and a few maybe new additional things. So my session is going to talk about descriptive statistics, inferential statistics, but the very common ones. I'm not going to go into every one of them because we don't have time. A bit about interpreting quantitative outputs, specifically looking at tables and graphs, and then a bit about responsible reporting of quantitative findings and avoiding misinterpretation. I mean, again, is one of the foundations or the important foundations of quantitative research. Okay. Okay, so I'm talking about common descriptive statistics, as I said at the beginning. And among descriptive statistics, usually people, we hear many times and often that we do descriptive statistics. Both Andrea and Justin have already talked about some of them or referred to some of them. So with descriptive statistics, we have two main categories. We have what is called the measures of central tendency, and these describe the sender of the data. It tells us about the magnitude of responses. 80% of respondents said that, so it's the magnitude. Or, as we will see in the next slide, I think the most commonly talked about one, as we have seen already, Justin at the beginning, he was talking a lot about the average, and in his next talk, you talked about the average mean. You gave both names for the statistic. So it also tells us about the magnitude. For example, the average household income in South Africa is XXX rands. So it just gives us how big the average income is for a country. For a maybe for the HSRC, the average salary is ABCD, something like that. It's one figure. We also have under descriptive statistics measures that explain the spread of the data, or alternatively called measures of dispersion. It tells us about how spread the data is, for example, because let's say if you had that the HSRC average salary is X rand, would you have an idea of how much people earn? Because it's just an average. The total divided by the number of employees, it doesn't give you, if you were looking for a job and you'd say, okay, I want a minimum of Y rands for me to get this job. But if you are given the average, you won't know, because we have doctors, we have professors, we have seen already on this team, we have everyone, we have administrators, we have people who sweep, we have people who do security, we do have everyone. So you won't get an idea of how much. It will not guide you. So we do have a lot under the measures of dispersion. At least those ones give us kind of how spread the data is. So both of these groups of measures include the mean, which was already talked about, the median, the mode, the range, the variance, the standard deviation. I will talk about a few of them. Next slide, please, Sakir. Okay, so the measures of central tendency, what exactly are they? So a measure of central tendency is a single value that represents the overall distribution of the data. It describes or identifies the typical value or sender of the data set. For example, the mean, the median, the modes. How do we interpret measures of central tendency? So they give us an idea of the middle of the data, but it's in quotes there to show that it's not really the middle. The only middle in the literal sense is the median, which when we arrange our data in ascending or descending order, of course, we go into the middle, and then that's the 100% middle. But still, even the average gives us kind of the middle of the, or sender in quotes. So the mean is the average value of a data set. It is a fundamental measure in statistical analysis, and it is the most common and frequently used method to measure the sender of a data set. I think on this point, you do agree with me. Like I said, we had the previous presenters talking a lot about the mean more than they talked about the other measures. The problem of, okay, so if it is the most used and frequently used method, why not only use it? Why do we worry about the other measures of central tendency? The reason is that the mean can be sensitive to outliers or skewed data if we have data that is skewed. And because of the sensitivity of the mean to outliers and skewness, the median is sometimes more useful. I think a very good example is the case of South Africa. I think most, if not all of us, know that South Africa is a highly unequal economy or society or country. So if we want to have an understanding, or if there's need for government intervention, and then there is, we use the average salary or household income, do you think government will be able to intervene? The average income is actually, because South Africa is a middle income country, but if we look at the lowest, then the picture changes. So in this case, in such a scenario, then the mean might not be very useful. We need the other measures to try and see the clear picture. So the median is the middle value of a data set when it is arranged in ascending order, like I said, or even descending order, because we'll still get the same result. It's just we're starting with the smallest or the largest number. It is the middle value if the number of data points is odd. Because, for example, if we have 9 observations, then 5 would be in the middle. It's very easy when we have odd a data set with odd observations. However, if we have even number of observations, we just go to the middle 2 and then add the 2 and divide by 2. That's how we calculate the median. But like I said, I'm not going very much deep into calculations. I'm just providing an overview. Okay, we also have the mode, which is the most frequent response or value for a variable. So, for example, I'm trying to use the examples which were used before. The migration categories table used by Justin. If probably the age 35 appears most for those who moved from rural to urban, then it is the mode. However, we can also have multiple modes. We can have, or we can have no mode at all, especially if we have a small data set. Or things like weight, again, going back to the types of variables as explained by Sakir earlier. Data like weight or height, sometimes we might not have a repeated number, especially if the data that we are looking at is not a very large data set. So in that case, we might not have any value appearing more than once. Andrea, I had an exercise. I'm not sure if it's ready or if I should proceed.
I can present it. Zaki, if you just stop sharing.
Thank you.
So same as last time, colleagues, if you have your phone handy, just scan the QR code. If you are using your phone to join, please open your browser and go to slido.com. Put in the number 35803053. Oh dear, sorry. Let's go back. All right, but it's like, can we go to the first question? So the first question is, choose the measure of central tendency that you think would be the best to give a better understanding of income dynamics in South Africa. Bandita, I think we need a definition of income dynamics for the non-economists here.
Okay, it's any of them, because I mean the inequality is almost everywhere, whether we look at household income or individual income. So or let's not limit it by which income. Okay, maybe let's say household income. Let's use household income to make life easier. If we want to analyze household income, which measure would we think is the best? Thanks.
So we have just over 100 people, participants that have answered. Let's try to get to 120. Okay, I'll move on. So 50% are saying the mean, followed by medium, and the least amount is mode. And it's it.
Thank you, Andrea. Okay, maybe, okay, I see there is a significantly, maybe not significantly, because we are doing statistics here, we need to measure the significance before I say that, but there's good number as well who say median. Actually, the mean just tells us, but it's skewed, like I said, South Africa is a very highly unequal society. So we have very few very rich households. And the average would mean that no one needs any intervention in terms of income. We wouldn't have social grants in South Africa if we used the mean, because in terms of average, almost everyone is fine. But it's because of the skewness, it's because of the outlier up there that make it, that moves everyone in terms of average in a good position. So the mean actually wouldn't be ideal, but the median, or at least both of them, the average is this, but if we look at the median, we find this. Therefore, we now want to move on to do more analysis, to do inferential analysis, for example, and other things. But the mean in a highly unequal society wouldn't be ideal as the only one. Okay, thanks. We can move back to the slides.
Oh, okay.
Thanks, Andrea. Okay, thanks. Okay, we said we also have the measures of dispersion, and how again do we interpret measures of dispersion? These measures describe the spread or variability of data points around a central point. Maybe just as a reminder again, when we talk about descriptive statistics, we are talking about a single variable. We are analyzing single variable. That's why we look at the mean and the average and how the points vary and so forth. It's just one variable that we will be looking at when we do descriptive stats. Okay, so they indicate how much data points deviate from the center to reveal whether the data is homogeneous or heterogeneous. Like Justin explained earlier, what does a small standard deviation mean and what does a large one mean? It means there is a lot of differences, but I'll come back to that in a moment. So common examples of measures of dispersion include the range. I want to take you back to when I talked about knowing about the salaries of an organization. Of course, most of the time it's not data that can go public, but in the event that it is public, or for example, for government departments or ministries, usually we know a director, a permanent secretary, earns this much, so at least we do have organizations where it's public. So if you get the average and then you get the range, at least you have an idea that the salaries start from this and end at this. And if your minimum agrees with what your minimum that you can accept for any job is in line with the minimum of the salaries of an organization, then at least you can get an idea. We also have variance and standard deviations. Justin did discuss in detail the aspects of standard deviation, and because of time, I will not go into detail on that. I wasn't going anyway because I said I'm not going deep. I'm just providing the foundations. So the measures of dispersion show how tightly or loosely clustered data points are. There's a typo there, how they are clustered around the center of value. And usually we use the mean now. How far are the other data points from the average? So like I said, the range is the difference between the lowest, which is minimum, and the highest value in a data set. To obtain the range, simply subtract the minimum from the maximum, and that gives us the range. And the standard deviation, again, is a measure of the distance of each data point from the mean. A small standard deviation indicates that data are close to the mean, while a large standard deviation indicates a wider spread of the data points. So quickly, again, my last exercise, Andrea, back to you.
Sure. Okay, so the question is, given South Africa's high level of income inequality, do you expect the standard deviation for income to be small or large?
Great colleagues. So now I think based on the morning discussions from Justin and these simple explanations, now almost all of us now understand standard deviation, right, colleagues? Thank you very much. Okay, so just to bring these two together, central attendance tells us where center of the data is, while dispersion tells us how spread out the data is around that center that we are talking about. A data set can have the same mean but different dispersions. Okay, I was supposed to give an example there, forgive me. Both central attendance and dispersion provides a more complete picture of a data set's characteristics. A very good example being the salary issue that I mentioned. The average will give us, on average, how much does people earn in an organization, but the range will give us what is the minimum, what is the maximum, what do we expect if I'm applying for a job. Okay, we could also even better still go to the level that you are looking at. If you are an economist with a master's degree, if you are an economist with an honors degree, you can look for information. How much do economists on your level earn? Or how much do policy analysts at your level earn? At least it will give you an idea. When you get that interview question, which I don't like a lot, of how much you expect to earn, then at least you would have an idea. So essentially, central attendance provides a summary of the data, and dispersion provides information about the variability within that data set or within that variable. Thanks, Sakir. Okay, now I move on from the descriptive starts to inferential statistics. Again, my colleagues have already touched on some aspects. So what is inference? Statistical inference is generalizing from a sample to a population. They gave detailed information on sampling and projecting the findings to the population, and when can we do that and when we cannot do that. So inferential statistics allows for realistic estimates, predictions, inferences to be made from the data. It involves use of sample data to estimate some characteristic of a large population and test a research hypothesis about a given population. Again, hypothesis, I think going back to yesterday when we started with the very first session. So these are what is done through inferential statistics. It allows us to make predictions and draw conclusions about a population based on a sample. So, but I have to remind colleagues here, we can only draw predictions from a sample about a population if the sample is a representative sample of that population. Otherwise, if we just come here and interview people here and then try to talk from the data that we get about people from Africa who are in research, it's very wrong. It's actually not acceptable, because we are not a representative sample in any way of people who are in Africa and in academia or in research. So for us to draw only if it's representative, and sometimes it happens actually that you intend to do a representative sample, but because of challenges that you face, you end up without a representative sample. We once had a study like that, I think it was in 2023, where we wanted a representative sample, but on agrarian households. We were doing a study to analyze the change or improvements or lack thereof among agrarian households in South Africa between now going back to comparing 2011 to 2023. So when we started, we were going for a representative sample, but there was no data for us to draw a representative sample. We ended up just getting databases from government. It was a government commissioned study, again, going back to the question of who exactly our clients. So there was limited information on databases of agrarian rural households. We ended up just interviewing the ones that we got. But in our analysis, we had only to do descriptive statistics, because we couldn't now talk about South African agrarian rural households, because it was not representative. In that case, we can only report according to the interviewed respondents. This is what we got. We will not talk about South African households because it's not representative. Okay, so while the focus of descriptive statistics is describing the data collected from a sample, inferential statistics help us to make inference about the population from which a random, emphasis there, colleagues, from which a random sample is drawn. It's not each and every quantitative or survey data that we can make inferences from. It's only a sample that is randomly drawn and representative of the population that we can do inferential statistics. So a few examples of inferential statistics include correlation, which measures the strength and direction of the link between two variables. We already have had examples before in the morning of this. So I think it was Justin, if I remember well, correlation doesn't tell us anything about causality. No, it doesn't. It just shows us that, I think it was Andrea, I'm forgetting the examples, I thought they were in my head. But it only tells us that student performance is positively or negatively related to being on social media for a long time, as an example. But there's no causality when we're doing correlation analysis yet. Then we also have regression, which predicts the value of one variable based on another. Now with regression, we move to causality now, because the tests there allow us to say performance is negatively affected to being on social media for too long, something like that. Okay, we also have t-tests which compare the means between groups to determine if there are differences in the two averages statistically. Are they statistically or not statistically significant? I want to take you back again to the example of Justin's table of migration categories. Those who remained in rural versus those who remained in the urban areas. For us to see if the average ages or whatever average you are looking at between them is statistically significant, then if we use t-tests and we compare, then only then can we say they are statistically significant or insignificant. Otherwise, those differences might not mean anything statistical. Thanks, may we move on? Okay, now I want to move on quickly to interpreting tables. I will not do outputs. We already have seen outputs when Justin was taking us through. For this table is from a study that we are almost finalizing on household food waste, which is a representative household survey for South African households across the country. Here, it just asks us on the most consumed meat type by households in a month. We asked the households and they gave us information. So we see that the most consumed meat in South Africa is chicken. Sometimes when we are writing our reports or our articles or whatever we are writing from the data analysis or the findings, I've seen where people write 69.28% of South African households consume meat, whilst the 20%, the most consumed meat by 20% is beef, and 8% is pork, and 2% is other meat. So it's not necessary because we already have a table with the figures. I mean, anyone can see. Usually, depending on what we are focusing on, usually it's enough, especially with very few categories like this one, it's enough just to talk about the main one and leave the rest. If maybe we have 10 categories, usually we report the main and the second and maybe the least, if there is any benefit in reporting the least one, but no need to report each and every one of them, because it defeats why we have a table in the first place. The table is for us to give people the information, the data for them to see. We can discuss just one or a few, but not each and every item. Okay, another important thing that we use, of course, people use different approaches and strategies. Here, I'm talking specifically about how we, the small team that work on food insecurity and agriculture and so forth on our team, is we don't want also to make people guessing. So how many, 69% refers to how many in terms of the absolute value. So we also put the number of valid observations, because remember, in a survey, sometimes some of the responses are invalid, but here we're only analyzing the valid ones. We don't need to analyze the invalid ones anyway. because they don't add any value. So we do put in the table exactly how much or how many respondents are we talking about. So those who want to confirm, they can just calculate 69.28% of 3,025 and get, in terms of numbers, how many households in South Africa said they consume chicken the most when they were interviewed. Okay, another important thing is when we have tables, make sure that you don't leave any room for doubt. I know quite a number of us here have already added up these numbers to see if they add up to 100, right? So make sure you don't leave any room for, for doubts in your data. Make sure your data is presented well and correctly to avoid such problems. Next slide, Sakir. Okay, so here again, we have a graph which is showing how households deal with leftover vegetables and meat from their meals. How do you deal? Because the focus of the study was household food waste in South Africa, but focusing on meat and vegetables. So we see that some of them immediately throw away. Then there's another category who leave it to use in preparation for the next meal. And so eat as leftovers before preparing the next meal, and reuse in preparation for the next meal, as well as put in the fridge or freezer. So these ones might not use it for the immediate next meal. They will put it in the freezer and maybe use it some other time, maybe freeze or use it after a month or something like that. So it tells us what they do actually with the food. So again, we can also see the magnitude or the size of households that waste food, because the red one actually are throwing away food. It's only the other three categories which do not throw away food. So in your analysis already, you might just also talk about the percentage that throws away food, that wastes food, and the ones that are not, in terms of food that is left over, in terms of meat and vegetables. Again, like I said, we in our small team always put the number. What are the responses that give us these percentages? Next slide. Okay, thanks. So on my last slide, I'm talking about responsible reporting of quantitative findings and avoiding misinterpretation. There's a lot of misreporting or misinterpretation that happens sometimes because we have our own agendas. There is a study that was done in a certain country. Today, I will not mention names, but it was on child support. People or women taking men to court to make them pay support their children. So the report came in newspapers saying, I think it was more than 70% of people in this country, more than 70% of men in this country are taking care of children that are not their children, because they had gone for DNA testing and 70% had said that. But this was just about 11 or so court cases where they went for DNA testing, and 7% of those 11 or so were not the fathers of the children. Now the newspapers were talking about the whole country, which is misrepresentation of facts, because it's not a representative sample. Like I said earlier, we can't talk about the whole country when it's just 11 or so people that had taken the children for DNA testing. So we need to be careful what we are saying and not try to lie and mislead using data. So I'll use this example. Okay, sorry, not my last slide, second from last slide. So one example is misleading data visualizations. So we can take these periods as maybe weeks or months or years, whatever we want. But we see the size of, this is a table, this is an abstract table from abstract figures. But we can see that the number of people or food recipients in this table per period is less than 200, except in period 8, where it's somewhere around 650. So when reporting, what do we do? Do we report that this NGO or whatever it is feeds people very much because they give them 650? We need to be careful because this might just be an outlier for some reason. Or maybe, take for example, during COVID time, we saw spikes in things like that, in food donations. But can we say this is the everyday thing we need when we are reporting to say it ranges between this and this over the period, except in period 8 where it was like that, instead of just reporting as if it's the norm. So we need to be careful and not misrepresent facts through our visualizations. Next, in my last slide, Sakir, thanks. We also have selective reporting sometimes, that is presenting only a subset of the data that fits our hypothesis. Remember, the hypothesis testing, sometimes I think we get carried away too much and wanting to defend our hypothesis that we forget what is important, for example. This happens sometimes through hiding data points or manipulating data to conform to the research hypothesis, or cherry picking metrics to support research hypothesis. For example, in the previous one, if we want to push an idea that the food recipients are many, we would overemphasize on the spike in period 8, but maybe it's just a random thing which doesn't repeat again. Okay, we also have misinterpreting data. And this happens sometimes intentionally or unintentionally. But if it's unintentional, then always have the right people to review your work before you send it anyway. That's why maybe we have reviewers when we're writing journals, we have external examiners when we're writing our thesis and dissertations. It's to try and avoid issues like misrepresenting data, maybe unintentionally. But people also can incorrectly analyze data, use statistics like the t-test or p-values incorrectly to reject or not reject a hypothesis that they have, because sometimes they do not know, and therefore it means they interpret wrongly and present findings wrongly. We need to always keep that in check. Okay, as a foundations, I think this is enough to whet our appetite and try and get more information on this. I had a question, but we don't have time. We only have 20 minutes left and we still have a bit to do. So I will end here, colleagues, and thank you very much.
Thank you. Thank you so much, Fanudzai, for a very insightful presentation. I think what stands out for me here is the reminder that it's not just about doing the stats, it's about interpreting them responsibly. So I would like us to take 2 or 3 questions before Andrea can present on the use of the AI. Please, colleagues, you can raise your hand to ask questions or put your question on the chat.
Sorry, Busi, there are already some questions on the chat. I can read them for you. Some were in the Q&A and the others were just put in the chat. Can I just read them for you?
Yes, please, Kukanyele. Thank you.
So this was one of the first ones, the very first, but this might not be directed to one's eye. Okay, maybe let me just deal with the ones that just came now. So the first one is it acceptable to use measures of dispersion on longitudinal data for different provinces in South Africa that measure a common variable? That's the first one. Should I go through all of them?
Sorry, can you come again on that one? I can't see it.
Is it acceptable to use measures of dispersion on longitudinal data for different provinces in South Africa that measure a common variable?
Okay, so if it's already different provinces, can we say it's a single variable? If we are looking at the GDP of Gauteng province and the GDP of Western Cape, can we say it's one variable? Because remember, descriptive statistics is single variable analysis. It's univariate analysis. So once we have more than one, I mean, it's already two variables because one is the GDP or whatever of one province and one is for the other. Right? We could compare now, but we have already moved to inferential analysis. The average household income for Gauteng versus average household income for Cape Town, are they statistically significant? We use t-test to measure that, but we have moved already from descriptives to inferential. Then again, if we are using longitudinal, we want to see the average household income in South Africa in 2015 compared to average household income in South Africa in 2025. We have different averages and we can only do inferential to compare them.
Vandusa, can I just add that the intent of a longitudinal study is to look at changes over time. So your variable might stay the same, but we are looking at how it changes across time. And in the social sciences, I don't think we have variables that are time-bound, that are not time-bound. So it wouldn't make sense to group all the income together for the last 10 years and then look at the dispersion. I don't think that tells you anything useful.
No, it doesn't. Actually, like you said, Andrea, the purpose of a longitudinal study would be to see if incomes changed from 2015 to 2025. So we actually need to assess the average household incomes. Are they statistically significant for us to be able to see any change or lack thereof? So it's no longer descriptive statistics. It's no longer dispersion, it's inferential. Any other question? Okay, I can see here it says, is there a specific approach to crafting the narrative from the outputs in the tables or graphs? For instance, from the example, if the most consumed meat is chicken, what does that mean? Okay, so before we even look at what does that mean, remember descriptives and trying to infer something. Here we are just describing the data. What is the commonly consumed meat by South African households? We just describe what is the, okay, the last census for South Africa, how many are women, how many females, how many are males? We're just describing, we haven't moved into anything else. So the table that I gave you, we are just describing. Then we can try to understand why do people consume. But when we go to the why, the descriptive is the what do we see? Then we go to why, that's another story. But of course, the idea is not only to end on the what we are seeing, but to understand why. And one of the reasons, as you said, or as you guessed correctly, is actually that chicken is relatively cheaper than other meat products. Thanks. I'm not sure if there's another question, Kukanyele.
No, all right. No, thank you, Vandutsai. I think we can pause for the questions and give Andrea a chance to do the use of AI. Then, if time allows, we can also go back to the questions before we close. Thank you, Vandutsai.
Thanks all. So I'm, can you see my screen?
Yes.
No?
No,
We can.
not
No, not
yet.
yet. How about now?
Okay. Yes, we can see it now.
Okay, great. I wanted to start with, so can you see my PowerPoint slide? Best practices for using researchers using AI.
Yes,
Yes?
Andrea, we can.
Yes.
Okay, great.
Yes,
All
we
right.
can.
So a few cautions, and this is the slide that I used yesterday during the ethics session. AI is becoming, it is a tool that is now part of a researcher's arsenal. It is allowing us to do more analysis quicker, and I don't think you can ignore it as a researcher. It is becoming part of the way that we work. But a few best practices when using AI. Always validate and review and cross-check your AI-generated analysis. Most models, ChatGPT, Claude, Perplexity, will hallucinate. So they will make up things. And so you have to be an expert in the area that you are writing about and analyzing in order to validate and review what is given to you. Most important, do not upload identifiable data onto AI platforms for analysis. Most AI platforms are cloud-based. They harvest the data that we put in and keep it because that's how the models learn. So if you are putting in people's names, their contact details, their sexual orientation, once that is loaded onto a ChatGPT or another platform, that becomes public knowledge. There are models, and on the fourth point, using ethically approved tools that comply with data security and ethical standards. If you're a qualitative researcher, Atlas TI has a AI plugin. From the best of my knowledge, that is end-to-end encrypted data security. So it doesn't share the identifiable data. But for the most part, always de-identify your data. And if you're a qualitative researcher, your transcripts. Disclose the use of AI in your methodology. How did you use it for analysis? Yeah, just acknowledge where it's applicable. The fifth point, avoid over-reliance. Like I said, it's a tool. It is not a replacement for you as a researcher. It is not a replacement for your critical thinking. It is not a replacement for your scholarly judgment. And just keep abreast of ethical guidelines. Most universities have guidelines. So the university I'm affiliated with, the University of KwaZulu-Natal, allows AI use, a large language model use, as long as you acknowledge it. But if you have used AI, then the marking criteria becomes much stronger. So they are embracing AI. UCT has just embraced AI as well. But other organizations have different guidelines. And lastly, ensure that the AI respects your usage respects cultural, social, and contextual sensitivities. Most of the data that AI software is learning from is global North Western data. And so cultural nuances, contextual sensitivities are often lacking in it. That being said, I wanted to show you a very short demonstration of how ChatGPT can help us with analysis. So here I have grade 9 student marks for, we'll say, for the year. You'll notice there are no student names here. There are only numbers. So this is de-identified data. We've collected their self-identified gender, their age, and then their marks for mathematics, English, and science. The data sets that you work with would obviously have many, many more rows of data and a lot of more variables. I'm just using this for the example. So what we can do is we can select this and copy it. And then go to ChatGPT. And the prompt that I'm going to give it is, okay, so here's the table that I've cut and pasted into it. And then I can say, please, we don't have to say please, calculate the average maths, English, and science scores by gender from this table. Right. So if that was my research question, I just at a descriptive level, I wanted to know what the averages are, but by gender. So I put that in. It will start analyzing. One thing to remember is on the free version of ChatGPT, there are limits to how much analysis you can do. It'll cut you off quite quickly. So here are the average scores by gender. So for females, I know what maths, English, and science is, and males, right? So I can also say calculate the measures of central tendency, which is what we've been doing, for each subject. Oh, calculate. I don't think it's so. Right. So it will do that. You can have a very general prompt that says, so here we have the mean, median, and mode for each, and this is male and female combined. And it is a nice example to show that how your mean and your median for maths are quite similar, whereas your mode, the most common score, is quite lower. And that's actually for across the subjects. So you can just have a general prompt that says, calculate all the descriptive statistics from this table. It'll help you understand the table a bit more. And then you can say here, write this up as a narrative finding. So it'll write up the results based on the analysis. So so this could accompany your table or replace it. The last point I just want to make is that tomorrow we have a session on data visualization. It kind of picks up from where Van Dutsai ended about appropriately representing your findings. It is quantitative and qualitative data visualization. So this is just a quick advert for that if you're interested in that. Thanks so much.
All right. Thank you so much, Andrea, for showing us how we can use AI. But also we have to be very careful when we use AI and remember that yes, it can support our work, but it should do that without replacing the critical thinking that good research requires. So I see that we have less than 5 minutes before the session ends. Maybe we can take some few questions and then I will wrap up the session. Just 2 questions. I see there is a hand.
Yeah, Bertrand.
Okay, yes, you can.
Yeah, please. I just wanted to ask a question. I see that you guys arrange for quantitative and qualitative analysis to go together concurrently. It appears on some days, and I just wanted to find out whether it clashes with some interesting these things that would have wanted to attend. Like I was interested in finding out both how qualitative analysis is done. I'm a natural scientist, yeah, but I came here because I wanted to see there's much more that you guys package as social scientists, yeah, than we do in our experiments and so on, yeah. So I just found out that I could only attend quantitative, but I would as well have wanted to attend some of the qualitative sessions, yeah. And I was going to ask if it is not possible to put that on 2 different days, so that in the future, if you have people who may not be necessarily social scientists who want to glean from both, just have an idea of what their
I mean, we will take that on board for next year, because we'll still be having this next year. It'll be our 7th year running it. But also just to remind everyone that sessions are recorded. You will we will post links in the repository to the video recordings of each session as well.
All right. Thank you. Thank you so much. Thank you so much, Andrea. And yes, I want to take these 2 minutes left to thank our presenters for such a well-structured and engaging session. I think
Sorry, Busi, there is on the Q&A, maybe it's just one question. Please provide an example of ethically approved tools.
Please provide an example of ethically approved. Okay, I will get back to you on that one. I'll put a list up in the presentation. But as long as your data is de-identified, you are covered. And as long as the data is not embargoed, so if it is public use data, you should be fine. Go ahead.
Okay, go ahead, Prof. Justin.
Yeah, I wanted to just add a comment. I think it was really great that Andrea is looking at AI and we need to engage and learn. But I don't think there are hard answers at this point in time, as it's really disrupting knowledge generation. I think that we all need to be very conservative and worry about taking anything kind of directly paste. I see questions around, can you paste answers? That would make me very nervous. But I will share a few things that I think I've learned from AI. and that is that, let's say you are unsure of a particular method or a particular approach with your data. You load it into ChatGPT and have a conversation. Ask it, what about this statistic? Or can I apply a different type of statistic? So you can rather use it as kind of like an instructor. I wouldn't be trying to use it to like directly do everything for you. I mean, you don't know, is it going to make a mistake or not? But you could certainly upload it and get a lot of quick answers and a quick sense of your data. But I think the best thing to do is to use it as a kind of instructor and as a guide to give you ideas and then help you understand why you're choosing what you're doing. Or if you've got questions, you can ask it the follow-up questions. So even today, if I'm reading a journal article and someone argues something or says something and I wonder about it, I can upload the journal article and talk to ChatGPT to ask it what it thinks about that journal article, or, you know, what are the limitations. So you can kind of use it as like an expert, but I would steer away from trying to get it to almost directly do anything from you that you're going to cut and paste. Anyway, that's my 2 cents. Thanks.
Just to add on that, Busi, if you allow me, there is a question again on whether you can copy and cut and paste, copy and paste the AI generated output. Just like our work is tested for plagiarism. Most universities now have the AI check. I'm not sure of the technical term. So just be careful, because if you are found wanting, I don't know what the consequences would be. So there is already testing for that if you just copied and pasted AI generated content. Thanks.
Thank you, Vanudzai. Are there any more questions? Maybe 1 or 2? Okay. I think we can wrap up this session.
So
Okay.
sorry,
Yes,
sorry,
Kutlwano. Okay.
So, sorry, before Kutlwano, Kukanyile, if you could help, some colleagues do not know where to find the recordings. So if you could guide them, please.
And also paste the link for the evaluation form, Kukanyile, on the chat. You can go ahead, Kutlwano. Thank you, Vanudzai.
All right, thank you so much, colleagues. This was a very insightful session. I've learned a lot. But now I would like to ask, how does one acknowledge the use of ChatGPT on their research, and without looking like we've been depending on the use of ChatGPT or just AI in general? Thank you.
Okay, just give me a second. I have a standard one that I use. I cannot find it. But it's just a sentence that I use to say, you name the AI that you use, and then as part of my methodology, I'll say, for example, ChatGPT was used as a language model to ensure grammar. Man, I wish I could find it for you. For grammar and sentence structure, something like that. But all what is the word? Conceptualization is the author's own. So you can say I used it as a tool to help me. You can say in your preliminary analysis. However, you still have to take ownership of it. So you still have to say that the conceptualization was yours. And you do it in a similar way when you say you're using SPSS or Stata as an analysis tool. It's like I use this version, but all findings and your discussion are the author's own, something like that. I will post once I found the sentence that I use, I will just post it into the chat.
All right. Thank you, Andrea, and thank you, everyone. A special thank you to our presenters once again. This was a great session. It's very unfortunate that we couldn't do the group activity together due to time constraints. However, I believe it would still be valuable for everyone to complete the exercise as a homework. So I think we can close this session and have a wonderful day, and please do join and enjoy the next session, which is the secondary data analysis. And please don't forget to evaluate this session. The link is on the chat. Thank you, colleagues, and bye.
Thanks so much.
Before
Thank you.
can
Bye.
I ask
Thank
how
you.
we
Bye.
can access the recordings?
I will provide more information. It should be on the repository within a day or two.
Okay.
Thank
And
you.
If you go to our repository on our website, the presentation and the bios and everything are there as well. Thanks, Imba. You can take over now.
Thank you so much. Let me try to start my video. Good afternoon, everyone. Apologies for the technical glitch, but I think we are good to go now. So we should be fine. Okay, I'm not sure if the video is showing, but I'm going to wave. Dr. Bernard, can you see me?
Yeah,
Okay.
we can see it.
Thank you. I'm going to stop sharing video. Thank you, everyone, for joining. I hope that you have been enjoying the session so far. Perhaps you can put on the chat if this is your first session or if you've joined other sessions. Please feel free to let us know whether you're a newbie or not. And once again, just to welcome everyone to this session, which is track A. This is fundamentals of statistical analysis. And our presenter, we are very fortunate to have Dr. Bernard Moketsli-Shalele. And Dr. Bernard will cover essential statistical concepts and methods. And just a brief overview, he's going to be using a software called JASP. I see some colleagues are posting whether or not they are newbies or they've joined at the sessions. So thank you so much for that. I would also like to introduce my colleague, who is Mr. Sonke Mtiapi. Mr. Sonke is a senior researcher at HSRC. And lastly, myself, I'm Dr. Inbai Naidu. I'm a chief research specialist at HSRC. So I'll just give my colleagues Sisonke a moment to say hello, and my colleague Dr. Bernard to say hello, and then I'll proceed with the bio. Thank you.
Can I go, please?
Yes, please do, Dr.
Hello, colleagues. Good afternoon, colleagues, and our prospective attendants. You are welcome to these fundamentals of statistics. Hi.
Thank you so much. Dr. Sisonke, over to you to say hello. Sisonke, are you able to say hello?
Yes, sorry for that. Hi, everyone. I hope you can see me.
Yes.
My name is Sisonke Mtyapi. You have already introduced me. Thank you very much. I'll be the technical facilitator for this session. Thank you.
Thank you so much. So without further ado,
Colleagues, I want to encourage you. We're going to be, Dr. Bernard is going to be taking us through a lot of material. So I'm going to encourage you that you please interact as best you can in the chat and the Q&A. We will see how it goes during the next 2 hours. We were hoping to start promptly at 2. We are running a bit behind time, but we will try to make up for some time. And there might be an opportunity to take a break here and there, depending on how things go. But I would like to start, and I hope that we have about 216 participants, which is wonderful. So I hope you are good to go. I am going to go ahead and introduce, just give you a brief bio of Dr. Bernard. As I mentioned, he is a Chief Research Specialist at the HSRC. He is also an adjunct professor at the University of Venda. And Dr. Bernard's expertise is in disaster risk reduction, climate change modeling, and project risk analysis. So I think we are all in very good hands. So without further ado, I'm going to hand over to Dr. Bernard to start sharing his presentation and his plan. Over to you, Doc.
Madam Chair, and without any loss of time, thank you very much for the wonderful intro and the reading of the bio. Let me start sharing. This is a very formal presentation. However, we should not be very formal. We should try as much as possible to interact. Let's formalize it through interactions, but still maintaining the formality it has. I hope the presentation is showing from your side.
Yes,
is it
perfect.
Okay. Okay. Yeah, at this moment, I believe that everyone has downloaded this software. It takes a few minutes to download and install. Usually when you have problems, it could be the issue of your connectivity, how strong it is, but otherwise it should just download and be installed without any challenges. But if you struggle to install it now while we are moving, don't stress, just be with me. You'll still be able to post questions and follow. And there'll be a link, there'll be a recording after this that you can use and then try to follow what was being said on in this session. So, so I should believe many of you at this moment have been able to download and install this. Yeah, at the end of this session, it is expected that you understand the simple layout and the functionality of the JSP, that is in short, including the drag and drop features and output pane to set up your data sets or files. Usually with the previous versions, the data file that was accepted by JSP, excluding all these complicated ones, was a CSV file MS-DOS. But with the current version, even your XLSX, your normal spreadsheet, is acceptable. You don't have to make any extension to your file. You just have to capture your data on your normal spreadsheet, and then JSP will accept it. These are good news as far as the latest version is concerned. And you should be able to classify the data properly in terms of the nominal scales and use the frequency tables and contingency table analysis. Compute and interpret measures of central tendency that include but not limited to the mean mode and median, as well as measures of dispersion, that is your standard deviation and variance, as well as the coefficient of variation, to create the box and whisker plot. Usually some people call it a 5-number summary, and descriptive plots to visualize the spread and distribution of our data sets, and then apply the APA format style of reporting and statistical outputs, ensuring consistency and academic and research communication. Be able to identify when to use what is called parametric and non-parametric statistical tests, and ensure based on data type and key assumptions, apply t-tests, both student t-test and the paired tests, to compare group means, either between independent groups or repeated measures. Use analysis of variance to compare means across 3 or more groups, that is through the use of the so-called analysis of variance ANOVA, and use the effect size, usually through the use of Cohen's D, eta square, to evaluate the practical significance of statistical findings. Assess the strength and the direction of the relationships between continuous variables using scatter plots and correlation coefficients, Spearman's and Pearson's correlation coefficient. So these are our general outcomes from these particular session. Yeah, JSP is just a statistical software, which is very, which I would say is highly competitive to our normal software, which is SPSS. Most people are conversant with SPSS, but JSP is quite user-friendly as compared to these other softwares. Some other softwares would require you to have basic knowledge on programming, maybe your R, your starter, and many others. But JSP is an open source package. You just get it there free, unlike all these others where you have to pay or you have to wait for your employer to pay for it in order to use it. So another important feature for this is that the moment you upload your data set, it automatically picks up, gives you the initial the initial classification of your measurement of scales. That is either your interval scale, your ratio, your nominal, or your ordinal scales. You don't have to go into a different pane to think of what kind of variable is this. It picks it automatically. And then it splits the pane into 2. That is your data set as well as the analysis pane. So, and in most cases, it tries as much to give you a taste of the analysis of the results. And then you just cut and paste all on your Word document. Then you're good to go. So as you push variables into the boxes, the analysis box, then on the other side, you see the outcomes. So that is how good JSP is. And it compares closely with what is one called Jamovi, Jamovi. That is another. But the goodness with this one is that it has a number of modules that are very strong, such as your structural equation modeling, which with SPSS, for example, you have to pay for that extension. SPSS, the last time I used it, it did not have the structural equation modeling module. You pay for that separately. On top of that, the very SPSS you have to pay, unless you are using a student version, which I believe could be limited in certain cases. So therefore, this one is a bit robust, and it has even added more modules than I ever thought, especially if you are a data-intensive researcher. So that is JSP. This is exactly what I've said. This is exactly what I've said as well, to say your nominal scales are already detected automatically by JSP. All you have to do is just to load your data set once you've captured it correctly. So, like I said, this slide is no longer necessary because this one will be speaking to the older versions where after capturing your data on your XLSX or XS, that is your normal spreadsheet, you would have to save that file as a CSV MS-DOS, but you no longer have to do that with the latest version. I was using that. I only updated mine yesterday so that I don't speak, I don't use the older versions when you guys are on a new version. So we are sharp, good to go. Now, it is time now to navigate our JSP interface. What does it look like? Once you have downloaded it and installed it in your PC, let us see what it looks like. I'm gonna stop sharing this and then go straight to my software, JSP. Let me open it. And then those of you who have downloaded it, let's go together. Let me try to share this. It looks like this. This is your JSP when downloaded and installed. You can see that the version we have is here is 0.95.0.0. That is the latest version. So here is how to navigate it. You just click here. First time you click here, it says, so open a data file and take JSP to spin. You click here, then that pops up. So remember, you would have saved your captured data on My Documents or downloads or on desktop. So I'm just going to take library data here, anything. Don't worry for now, I'm just trying to load some data. Now, once your data has been loaded, everything will look like that. Now, let me go back. I'm going back, close this. And if I do, there I am. Then you click here. If you want to load your own data set, I said this time around, you don't have to have any extension, your CSV file. Your normal spreadsheet file will be acceptable with the latest version. You'd click your computer and browse, that is, look for where you have put your data set. If you put it on desktop, then wherever you've put it, then you should be able to get it. So now, because I'm just demonstrating the interface, let me go and pick anything and then assume that we have now loaded our data set. It looks like that. And from the look of it, it doesn't look threatening. It's just a very, very, very user-friendly system. You know, sometimes some of us are technophobic, you know, when you are confronted with the software, there are a lot of iterations and a lot of modules that you have to click on. But at least this one, the moment you open it, you can smile at everything is clear, crystal clear here. Yeah, so it looks like this. Now, yours may not be having these modules. It may be having a few modules up to factor. 1, 2, 3, 4, 5, 6, 7. It might have 7 modules. You may not be having reliability and time series. Now, you can add more modules on this, I don't know what is a ribbon or whatever, or taskbar, whatever. You may. So there is a plus sign over here. When you click here, you will see a list of modules listed there, and then it's up to you to pick the one that you think you may use or you like. So in this case, if I uncheck this, you'll see that the network analysis is gone, module is gone. If I pick power statistics, that one is loaded. If I pick profit for predictions, then it is loaded. Now you don't have to worry. Yours might not look like mine because you see this is checked. Yours might not been checked. This is the structural equation modeling, very powerful module, time series. You see, you can play around and add whatever that you think will be important for your research. Fine. And also quality controls are here. yeah, everything is good. Let me leave it like that. Then you click anywhere, everything comes normal. So you can add and remove modules as a need arises. So at this moment, let me take you through. If you click here, for example, we have, assuming we have loaded this data set. Now, the moment you load it, you can see over here, there are 3 variables here. There is extra, I don't know what it is. Maybe it's extra, whatever extra it is, extra class, extra, whatever it is. There is there, you can see, you see a ruler there. And then for group, you see 3 cycles. And for ID, you have those 3 bars. So with the group one, that illustration are near the group, it tells you that particular variable is nominal, is a categorical variable. So automatically JSP, when you load that data set, it labels it as nominal, as categorical. So even in the analysis, the moment you analyze, it will show that the only acceptable nominal scales are scale or categorical or ordinal. It tells you straight. Otherwise, if you push a variable into the box, it will reject it. That is how smart and user-friendly it is. So unfortunately, from theory and from what we know, we have 4 nominal scales, scales of measurement. Your interval, ratio, ordinal, and nominal, which is / categorical. But here, the interval and ratio, continuous discrete, is named as 1 under scale, which is this ruler here. When you click there over that ruler, it tells you that there are 3 scales of measurements, which is scale, which is a combination of the interval and the ratio. Then you have your ordinal, which is your agree, disagree, strongly, whatever. That is the kind of scale. Then your categorical is there, which could be your gender, male, female, age groups. Yeah, automatically it picks it. You're good. But there are times when you feel that now, man, much as this is ordinal, in my view, or the way I want things, I want this one to be scale. Although it might be discrete, but I want it to be scale. Then you click over that icon there, and then you change the way you want to change. Because you might have realized that in your analysis, JSP is rejecting ordinal scale, but it wants scale, scale. I think you understand, where scale is a concoction, a combination of the interval and the ratio scales. Then you're good to go. So another thing is, I might double click on this. When you double click on this, you see another pane popping up. So you see there are values, filter, whatever labels here. So usually when you capture your data, let's say you have sent out questionnaires to participants, and during the capturing of your data, you had a male and female, you had gender, that demographic variable gender. Then when you captured your data, female was 1 and male was 2. Because during capturing, you cannot be writing female. You might write female with a capital F, and then in certain cases write female as a what is it? Not capital F. And that may create problems as far as the analysis is concerned, because the system might recognize female with a capital F different from female with a non-capital F. So therefore, it's good to capture your data like 1 means male or female, then 2 is a male. Just capture like that and load your data. And then once you've done that, you can change everything here. Let's say this was captured in terms of, I can play around. Then I click here, then I remove that. I can write male here. Then once I write male, then I can click here. The moment I click the other one, then you can see that all the ones are males. All the ones are males. Then I can click again, and then let me female these 2. Then for it to apply, you can click up once. Everything, that whole column is now changed. So even if you had captured your data like 1, 2, 3, 1, 2, 1, 2, then you just change them. Once you're done, then you can close that page. It says apply. It means everything has been changed, but now the system wants to save it or apply. Then you apply. Now you're back to your data set. Good. Then what else is important here? I think this is it. This is taking you through the interface of the software. Loading data, just load it as it is. No need for any extension anymore. Load it as it is. And then these are the modules. If you need more modules, you add. And then you're good to go. This is how simple it is. Any questions so far? My colleagues will help me with questions coming from the chat so that I don't have to total presentation and that.
Thanks, Doc. I do not see any questions. Colleagues are saying they have been able to download. I've also asked if anyone has actually used the software before. I've not seen any response to that yet. But I think we are covered for now.
Sorry,
Thanks.
can I come
Okay,
in?
there is, sorry, but there is a question on the Q&A.
Okay, thank you.
From my friend, I hope I'm able to pronounce it well. They're asking if should the analysis from JASP be considered reliable, seeing that it is an open source and free?
JASP has been used extensively in the research space. Hello? Or maybe someone's mic was. JASP has been used extensively in research. And even recently in several international conferences I've been in, they use both JASP and Jamovi. But JASP outsmarts Jamovi in terms of the number of modules added. And if you are in doubt, you can juxtapose the results from JSP as with those coming from other statistical packages. You'll get the same result. Yeah, the only thing when it comes to the structural equation modeling is that the structural modeling package that is embedded in JSP is variance based. That is the only thing. It does not have the other grouping of the structural equation modeling, which still does not pose any problems. Then all is good.
Thank you, Doc.
Yeah.
There is a question from the chat. And the question is, can we run any analysis for demonstration? I think you do have some training data.
Yes, exactly. I'm going to that.
Thank you. Okay.
Yeah, I'm going to that. Let me stop sharing this one and then go back to my presentation stuff. Here we are now. We have now gone through the interface of JSP. Now it's time for us to do some demonstration, to do some magic and to show what this JSP does. So if you have the data sets already, then you can follow me. Let's do this together. If not yet, there's no problem. Just observe and then come up with questions, if any. Then at the end of this, you'll be able to do this yourself. All right. Now let me stop this. And then, am I still sharing? What? Am I sharing the software at the moment?
Yes, we're seeing the data.
All right.
Yes.
Let me do this. Now I'm exiting this, close it. I don't want to save it. There it goes. It's gone. This is what you normally have once you open your software. Now, then I click here. Then I'm going for my data. And then I browse anyway. I'm going where I saved my data. So you'll do the same where your data, where your data is. Let me see. I saved my data is here, 2025, blah, 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 training statistics. academy, blah, blah, blah. Don't worry about all these things. Now I'm looking for data. Yeah, descriptive statistics. That is where we start. Then you see the files that are accepted here. This is a list of file extensions that are accepted. Like I said previously, there was many other types of files which could be complicated to people who are not quanti, to frustrate. But this time around, our normal XL as X is acceptable. Good. Then I just open that, and then the data is loaded. And you can see automatically the scales of measurements are already determined. So that is how good it is. So now, let me do this. We are doing descriptive statistics now. So if that module was not there, we would have to load descriptive statistics module, but usually the first 7 or 6, they come by default with the software once downloaded. So now I'll click on my modules, descriptive, then descriptive statistics, click there. Usually, this you do in your first section of your questionnaire, which is demographic section. Remember, you would have maybe your first question would be on gender, then the other one on age, the other one on economic, income levels, whatever the case might be. So we are I'm actually demonstrating how to analyze your demographic section variables. So here we are. So now, immediately you can see, once I do this, okay, let me go back again. We loaded our data set, then you click there, descriptive statistics, there you go. You have your variables here, then you have your variable box here. We push these variables into this box. And immediately once you push this into here, then the results will be over on that other side. That is how good it is. Now, we see that as far as this box is concerned, it does not care about the kind of scale that must be pushed into this box. If it was, it cared, then it would put a ruler here to say it can only accept the scale or the interval ratio scale. But this time around, it doesn't matter. So let's now try to analyze the wages of these guys. I don't know what it is. These guys, you push that variable there, you click there, it goes. Or if you wanted to push many, you can click, press Control, click, press Control, then select all of them at once and push them there. Or you can push them one by one. So I pushed one, which is the wages in thousands. And then I may want to split this into gender. Let me do that. Split it into gender and put gender over there. Let me see. Oh no. Because wages could be ratio. Let's go change it. Sorry, let's go change it. Let's go change it into scale. This could be continuous or discrete. It's just for demonstration purposes. Go back, click there, descriptive, and then push wages into that box. Perfect. Yeah. Now let's split this into, because we have statistics here, but now we want to display our results in terms of gender to see for now males and female, what could be the difference if we're interested in terms of mean or any other central measures of tendency. Here we are. So you push variables into this box, then you have outcomes. Then you come here, there is transpose here. If you feel that there are many variables, there are not many groupings horizontal, and that may exceed your margin of your MS Word, you may transpose that. You click here, transpose, you see, you can play around to lay it out the way you want. So there's transpose here, you check it in, check it out, and then just to fit your taste. Then the other thing, anyway, I like this one for now. Then I can click statistics here. Once you click statistics, this is valid. The valid is just the sample size. I don't like it for now. It's up to you. Missing, there is no value missing, but I don't like it. But I'm interested in the mode, in the mean and the median and the mean. That is it. So you shouldn't worry much about the narrative below the table, but it is important as we go on. But for now, it's not an issue. You just check out the statistics that you want. Maybe if you want the sum, you can do that. If you want variance, you can as well do that. If I don't want maximum, minimum, you can look at, you need the range and the interquartile range. You're good to go. Everything will be displayed wonderfully. Then once you have this, you can now, let me go back and focus on the central measures of tendency and dispersion. Let me take mean mode, tendency, and dispersion. Let me take variance. No need for standard deviation, but the two are related. One is the square root of the other. So here is what I have. And then I want to take this to my Word document. Then if there were 3 or more tables here generated, I would click here. You see the downward arrow. If you click here, it highlights all the tables. Then you can copy and paste on your Word document. Then you have a wonderful table with no grid cells like those coming from directly from spreadsheet. So this is it. But if you want one single table, then I click here. This one downward arrow, then I copy and I go and paste it. And that's it. That's it. Then I'm good to go. Then I can make some reporting to say the females mean, the medians were the same, whatever you want to say. You can now speak your multiracial English around these output. Then you're fine. So if you want to go back to the data page, you click here. There's an arrow here. You click here. And then if you can't see it, there are 2 arrows here. You click one there. You are back to your data set. If you want to go back to the analysis part, you click the arrow on the other side. You click there. It takes you back. So this is how to total between these panes. Shouldn't worry. Then if you want to get rid of this, you can cancel it here. Then you are back to the original data set as you loaded it into your system. This is it on descriptive statistics. But now, let me stop sharing this, go back. We now have our output. We click on that downward arrow above the table of interest, and then we paste it on our Word document. Then, once we do that, we can now report. Now, the reporting is something else now. We need to report in an APA format. That is one statistical way of reporting our results. So I'm gonna project this for you. Let me stop sharing here. Let me share this again. To say, remember, we now have, can you see the statistical reporting here?
Not yet.
Okay, let me do that and share. I've now pushed the variables into the analysis box, and then the results are now on the other side. Now, let's say now I've selected the statistics of interest. In this case, I have checked the mean and the standard deviation, the median and the mode, and the coefficient of variation put together. It depends on what I want now, maybe given my objectives or what I want to do. So now, remember, in that analysis, maybe I wanted to see if there's a difference maybe between these 2 categorical variables, which is gender, between females and males in terms as far as the wages are concerned. So now the reporting, the APA reporting, remember you can report anyhow, but then when you report, you make sure that you put your reporting in this particular format to say, whatever you say, you put your mean as M equals whatever value, comma, SDs for standard deviation. You pair the mean and standard deviation together, and then you say whatever that you want to say. Now, here is a basic reporting. It should look something like this to say for clinics, let me see. Do we have clinics here? Oh, no. I compared gender, over wages. Let me go so that you can relate to this. Let me go back. There were two categorical variables there. Let me go back. Yeah, tell me, you can see this projection here. Can you?
Yes, we can.
All
Thank
right.
you.
Yeah. So I did analysis over gender and wages, but this time I want to do wages over the health facility, so that reporting, because I did that reporting based on this categorical variable here. So let's go. You click there, statistics. Descriptive statistics. Now I push my wages, which is a variable of interest, but then I want to split this in terms of the facility. There we go. Then I go to statistic. Don't like this, I don't like this. Don't ask me why. Then I like this, I like that, I like this, I don't like this, I don't like that. Give me coefficient of variation here. Where is it? Let me go. It's here. Coefficient, that is dispersion. I have it. And what else is of interest to me? Yeah, whatever it is. Then here I am. Then I click here, and then I copy this and put it on my Word document. Boom, I'm smart. Now I go back to the reporting. It's now time for reporting this demographic section of variables. Then let me go. Is it projected, the reporting?
Yes, it is.
Yeah. Now, it doesn't matter what to say, but what is important is reporting in this particular format or fashion. For clinics services, wages were relatively high with a mean of bracket M equals that 5.3 with a standard deviation of 2.37. Then the median of 5 and the mode of whatever, blah, 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 blah. Use your multiracial English, like I said. But what is important is to report the statistical part in the APA format. That is very, very, very important. And then we note that across all services types, that is your health facilities, the medians were consistent. That means they're almost the same. Although the mean difference suggests a slight variation in wages levels between the three stated categories. It depends on what you want to say. It depends on objectives. It depends on your study. But this is just to give you a taste of how to report your results in statistical, APA format. That is the descriptive statistics on how they are reported. Rather than saying, just writing to say, I don't know. Let me not go there because I don't know how to confuse this. All right. Then we move. Let's move again. Then I can entertain questions, if any, on descriptive statistics. Otherwise, I go to hypothesis testing. Hypothesis testing. In the absence of questions, let's go into this, what is called parametric and non-parametric testing. Let's not go into deeper details. Parametric testing, there's a number of statistical tests that you can deploy. Some are parametric, some are none. What does it mean to say they are parametric? It simply means there are key assumptions attached to them. An example, you cannot do PhD before master's. I'm just saying something. So that assumption when you do PhD, that you have done your master's, is important. Otherwise, you cannot be admitted to a PhD if you have not done master's before. So that's parametric. Non-parametric, doesn't matter whether you did master's or no master's. As long as you have interest in PhD and you are capable, let's go. I'm just saying. So parametric, key assumptions, and they must be satisfied. Otherwise, no-go area. Non-parametric, it doesn't care. But usually statisticians say the parametric ones are more, maybe I like words, maybe more reliable than non-parametric, but they give acceptable results. Maybe I would say it's a similar argument to say quantitative versus qualitative. These are different schools of thoughts where others would say quali goes deeper rather than objectivity, these objective kind of results where 2 + 4 is equal to 6. So it doesn't say anything about people's emotions or whatever, but they are both acceptable, or a combination of the two is acceptable. So it doesn't really matter. So, but what is important, prior to the usage of parametric tests, there must be key assumptions attached to that particular test that must be satisfied. Otherwise, you don't go, don't proceed. Rather, shift to parametric or apply some transformations to that data set in order to proceed. So that's another topic. That's a topic for another day, of the transformations in case your key assumptions are not met. So let's see. And then we are going to look at the t-test, ANOVA correlations and contingency tables. So now let's land on t-test, usually student t-test. When do you use it? There is what's called independent t-test. We compare two groups, strictly two groups. If there's group A and group B, we want to compare these two groups over one variable. Maybe there is class A and class B. We want to compare their performances in mathematics. So there are two groups. We want strictly two. If it's more than two, then t-test is out. It is something else. And t-test has both parametric and non-parametric. So the moment we test, we must look for the key assumptions. If they are met, then we continue. If the key assumptions are not met, then is either we shift to non-parametric or we transform our data. It's a bit complicated for this particular session here. So we'd rather move to non-parametric. Good, let's go. Let me see. All right. Let us have this hypothesis first for us to grasp t-test. Remember, in your research, you may have your research questions or objectives or both. Or in certain cases, they might say, if you have hypotheses, there's no need for objectives or no need for questions. Maybe depending on the discipline. Science disciplines, they may be interested in hypotheses rather than objectives and research questions, but some just want everything. So here's a null hypothesis to say there is a significant difference in mean wages between males and females, female employees. So now, in fact, there's no significant difference. There's no difference. And once we say there's no difference, in other words, we are saying the mean values in wages is the same. Mean for males is the same as mean for females. That's what we are saying. Alternatively, we are saying there is a significant difference in mean wages between these two genders. So if there's a difference, then the equality sign does not hold. Or we may want to test this to say the males have a greater mean, meaning males are any more than females. That means the mu female, which is the mean for males, is greater than mean for females, or the other way around. That is what we can test. Now, let's land on t-test module. Stop sharing this. We use the same data set for descriptive statistics. So now I'm gonna click this out. I've checked it. We are here now. So t-test module is here. Then you click there. No. T-test. T-test is the independent. Click there. Then there we go. And then we are, you see now, the moment we come to t-test, remember, we are comparing two groups over one continuous variable, or not continuous, or one scale variable. Now, the scale variable, which is dependent variable here, is the wages. And it tells you that in this box, what is acceptable is only the ruler, is only the scale. The group variable is not acceptable. If I so want to push it, then I have a problem. It is not welcome there. Take it out. When you take it out, you just click on it again, click on it, and then press that arrow, it goes back. Or you can push many into that. So let me push one, no rush, put it there. Now, remember I'm comparing males and females. Then I push that. Then I have a good table of the independent t-test. But I'm not yet done. I've just pushed variables into the analysis box. Remember, there are two groups, parametric and non-parametric. First, I must check whether this parametric, by default, whatever you do is parametric, unless you change it. So now, there are key assumptions. Now you move, you look down, you see there are assumption checks. And the first assumption there is normality. And it doesn't matter, all the assumptions must be met, must be upheld. Otherwise, if one of them is violated, no-go area. They must both be upheld. Otherwise, it's a no-go area. But before then, let's check what we are doing here. Remember, the first hypothesis was there is no significant difference between the mean wages of these two groups, males and females. Then we said the mean wage for males is equal to the mean for the females. But alternative hypothesis we are testing here, the two are not equal. So this is checked. It's checked already. So we have the result. Let's change it. Let's say group 1 is greater than, the mean for group 1 is bigger than group 2. So which one is group 1, which one is group 2? So once you check here, there will be some notes underneath your table to tell you which one is group 1, which one is group 2. According to these, we are testing whether, we are saying group 1's mean is bigger than group 2's mean. And what is group 1? For all tests, the alternative hypothesis specified that group, that is 1, female, is greater than group male, meaning group female is group 1, then male is group 2. So in this case, we are saying females are any more than males here. So that is what we are testing. Then it depends on what you want to test. You must always be careful of what is it that you want to say. Then you check the appropriate box. This case, then you say they're not equal. They're any different. So then before I take this table, let me go check the assumptions. Check normality, check equality of variance through Levene's test. It might sound something, but let's do that. So we have key assumptions here displayed in two tables. Normality test through what is called the Shapiro-Wilk test. Then we also have Levene's test here. Now, even if you don't know much in statistics, let's read here. Significant results suggest a deviation from normality. In other words, the variable of interest, which is wages, must be normally distributed as far as normality is concerned. But according to this, there's a deviation from normality, meaning that particular variable is not normally distributed. It doesn't matter what Levene will say. The key assumptions are violated already. Whether just if one is not upheld, throw everything away. That's what we do. So now, here, we don't even check here. So, but then, let's see, if there's a deviation from normality, how do we know if this was not the case? If this writing was not here, then we check the p-value. You don't worry about all these things. Just check the p-value here, the p-value. P-value is the probability value. Don't worry. That is it. It's like our yardstick to measure. It is what tells us what informs us to make decision as whether the hypothesis we are testing is significant or not significant. Don't worry about all these numbers. Just look at the p-value. So let me take a pause here. A p-value is like our measurement stick. So even in the first one, we have a p-value. We have p-value here, we have p-value, we have p-value. Across all these tables, we are looking at p-value here. That is the inferential statistics, basic inferential statistics. So now let us interpret this very one to make it simple. Now I tell you to say, if p-value is less than 5%, if p-value is less than 5% in decimal form, 5% is 0.05. Usually it is written in decimals. If p-value is less than 5%, then the results are significant, statistically significant, simple. Then it depends on what you are testing. If p-value is above 5%, the results are not statistically significant. So now, look at this p-value of normality test, given that there's a deviation from normality with our variable of interest, which is wages. Now, you see that this is 2.7%, less than 5%. There is a, remember, there is 0.027, which is 2.7% or 0.027. That is less than 5%. It means the results are significant. It means now we interpret to say when normality test should not be significant. Once it is significant, then there's a violation of the key assumptions. Throw away. If Shapiro-Wilk test p-value is non-significant, then our variable is behaving the way we want as far as parametric test is concerned. Then we are good to go. Here we are not good to go because one of the key assumptions are violated, no-go area. Then what do we do? Because we want to test whether there's a difference in terms of wages between males and females. Now, because the key assumptions have been violated, then we don't have a problem. Uncheck student t-test. Now check this guy, Man Whitney. He is a non-parametric test closer to our student t-test. He's an alternative in case things are tough. So we check him. Once we check this guy, you may not necessarily have to uncheck this. You can put it very cosmetic. You can increase. You can confuse people here. Just leave it there. Leave it unchecked and add this one. But remember, when you report, you must report that you must not report the student t-test. Why? Rather report the violation of the key assumptions and then land on Man Whitney, who is non-parametric in this particular case. So then we're good. So there was a deviation out, then our results are here. Whatever we're interested in the p-value of non-parametric test. But if the key assumptions were upheld, we would still consider this one here. Remember, this is just key assumptions. But you must take these tables, put them in a Word document, and you report. Whatever report you make, then the examiner or whoever marks your work must be able to see that which you are saying. Then another thing that we can do while we are here, then let us, okay, I want to take you back just a little bit. Let me check this box, descriptives. Oh, no. I wanted the box. No, plot, not this one, a plot. A plot is going to plot the means, the two means. Now, I want to visualize this and be able to finally interpret this. I was on the key assumptions. One is violated. I went to non-parametric, Man Whitney. Now, I want to visualize. Now you can see these two means plotted here. You can pull this a little bit here. If you so want, if it looks weird, come back and pull it down the way you like it. Good. But now these two plots, you can see those plots. They are more or less the same. Before you interpret the first table, they are more or less the same. So right from here, you can say something to say the difference between these two groups in terms of salary or wages, they're almost the same. They're almost earning the same, just looking at this without saying anything. But if one bar, let me call them bars, if one bar was slightly higher than the other one was quite low, we would know that whatever was high, those guys are earning good. And then there's a big difference. But let's not talk big here. We are yet to talk about the effect sizes. How big is the difference, if any? So now, here we can see these people are more or less in the same way. So I might want to see that in terms of the means. If ever I did not do descriptive analysis, I click, then I check the means. The female is 4.9. That one is 5. And what do you see with that? Immediately I can see, yeah, correct. The visual representations of the means, the mean plot is correct. To say, really, there is no big difference between the means in salary of these two groups of people. 4.9 rounded off to the nearest whatever is 5. 5 rounded up or down is gone down, still 5. Basically, these are the same. No difference. So therefore, the alternative hypothesis we're testing to say the two groups are not equal. Instead, they are. Let's go and report. And what do we report? And how in APA format? Let me stop this and go. Here we are. These are our hypotheses. But now with JSP, you did not see the null hypothesis instead. Remember the null, the alternative is the opposite of the null. So we tested the alternative. When we know the alternative, we as well know the null. So we're still covered. Now, let's go now to our, where are we? Oh no.
Doc, while you are moving to your next slide, just to let you know, we are sitting at just around 3:10. Just wanted to mention that. Thanks.
Okay.
I can see you having a lot of fun, and the colleagues online are enjoying it a lot.
Thank you very much. All right. Let me see. Let me see. I wanted to take you to the reporting part of it. It looks like I didn't put the report here. Fine. Let me go back to say, let's now, at this point now, you can take all these tables and put them, but I would suggest that you, between this and this, these two, descriptives and descriptive plot, just take one, because otherwise this is one and the same thing. This is just for you to visualize the differences, if any. This is the same thing just to see what exactly is happening here. So take one, otherwise you'll have a number of tables, and that may annoy examiners to say you are pushing pages. Then, but these ones I must. But now, remember our conclusion based on this last two table and the figure here. We see that there's no difference. So now the question is, that is the correct outcome. So now we have to say that based on the first table, remember, and where reporting on the p-value, straight on the p-value. So what is the p-value here? Whitman-Whitney, given that we resorted to non-parametric because one key assumption was violated for student t-test. So now the p-value here is above 5%, and that is actually 89.5% or 0.895. We're bigger than 5%. So now, how do you interpret that? We said when P is less than 5%, we have statistically significant results or outcomes. When P is above, none. So what are we testing? We are saying the two groups are different. And how do we know that? We checked this group one is not equal in terms of mean, is not equal to group 2. So what does that mean? It means both female and males are earning almost the same way. And that is attributed again to the descriptive table as well as the descriptive plot. Then we are gone. But now how do you report it? This is how you report it. Usually when you report it, because I've not done that, I want to put this aside. Let me do this. When you report it, looks like I did not, let me show you how you report it. You take the T statistic, and then bracket. Bracket here is DF. That's the degree of freedom. You give the value, and then you give the value of the P, and then you know how to interpret that. That's how you report it. Now let's go back to our results in table 1. Then we go. What is the T statistic here? Is for Mann-Whitney, because you know we have to report on Mann-Whitney because our student failed. So Mann-Whitney here, it is this value, so big. I'm lazy to write that one. Let me say, in terms of X here, let me leave it as X. That's Mann-Whitney. That was 1 point whatever. Let me be lazy. And then DF is called the degree of freedom. Let's go for DF. We go for DF. DF is 98. Just take it. Go for 98 DF. You put it here is 98. Now, what is the p-value? The p-value, it was 89.5. If I remember, that is 0.895. That was. And usually put this in italics. Don't ask me why. We have put it in italics. Usually Leonatiana put it. Then you can now write your nice English with the proper interpretation that there is no difference in terms of mean wages between males and females. Then you drop this as it is. This is the APA format of reporting the student t-test. We are done as far as student t-test is concerned. So the examiner wants to relate what you are saying with these outcomes. Maybe you'll have said table 5.1 depicts the results of student t-test, blah, 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 blah. It is clear that the females are not any, there's the results. And whoever is reading that can relate what you have dropped here in the tables. And you make sure that in your reporting, you make reference to your either figure or the table. Then you're good to go. You have not lied to the examiner. You are fine. Your aim was to see if there's any difference between the two groups or one group was any bigger than the other. You're gone. Any questions before now I land on, right? While we're still there, I want to make an assumption. Let's say when we tested this, we found a different outcome to say group 1 was earning better than group 2. Let's just assume there was such a case, either through parametric or non-parametric testing. Either way, the reporting is the same. So now there is what is called Cohen's effect or effect size. Cohen's eta square. Those are Greek letters used. So now, this is the interpretation. If Cohen's effect size is around 0.2 or less, somewhere here, then the effect size is very small, meaning we can expect our test that we have just made to have a very small effect size, because we could see that one mean is 4.9, the other one is 5.0, blah, blah. So the effect size is expected to be very small, meaning that the difference is not there. But if there was a difference, then we are interested. Is this difference that huge or medium, that is large or medium? It is another thing to report. So if it is large, it's around here. If it is medium, it's around there. So let's go with the same analysis, let's activate the effect size and see. And what are we expecting? A very small one, because there is technically no difference between the means of the wage, the mean wages of those two groups, males and females. Let me go. And then here we are. Effect sizes is here. Effect size. Now check effect size. Then don't worry about these others. But they're interpreted more or less the same way. Now let's check Cohen. Now the results of Cohen are, where are they now? Where are they now? They must be, let me uncheck and observe, check and observe. It is added now as the last column in the first table. Now you're interested in the effect size, Now remember, the student t-test was violated. We're not interested. Brown-Whitney's test, got it. Now, let's check effect size is here. This is 0.016. Then we go back to the interpretation of the effect size. And what are we expecting? Very small one, indeed. How may I go back? My presentation. Good. Around here, small. Ours is even smaller than this. Very small. So meaning, good. If there was a difference, then we'd be interested. How large is it? We would pick it up here to say Cohen's eta square or eta is large enough to warrant a significant difference. That would be good. So meaning here, I'm sort of done with student t-test. I can land on ANOVA, analysis of variance. Where we are coming from, we were comparing two groups over one variable, male, female over wages. Now, when the groups increase, student t-test cannot work. We would rather resort to ANOVA, which is in full analysis of variance. It is used when we compare 2, 3 or more groups over a single continuous variable, for simplicity. Now, remember, parametric and non-parametric. The first thing we need to do is to check assumptions. If one violated, resort to something else. All right, let me go. Let's go ANOVA. While I'm trying to go, I might entertain questions with student t-test as I'm trying to total between pages here.
Hi, Doc. Yes, so there are a couple of questions for clarifications in the chat. If you could explain what is significant and what is non-significant with regard to the p-value cutoffs. And there's also a trick question on the chat. If the p-value equals 5%, are the results significant?
Hey, you have a problem. Hey. Just on the dot. Is neither no.
Yes.
Yo. It would mean, what would it mean? I haven't come across it. This is a very big question for me, but I like it. You know what I would look at? We would look at just quickly 5%. No. Because remember, we may have 0.05. Let's say the third significant value is 0, or another case 0.059. We would have to try to do some rounding off and come to a conclusion there. But check the results here. Check, okay. The results here come in 3 significant values. Figures. So to say, but I see the trick. because let me go to the questioner's trick to say, what if you have 0.050? Yeah, I think that is where the catch is. Because if I want to round it off there, the zero goes down and I'm still left with 0.05. I've never come across such a thing, but I'll look at it honestly. I'll look at it. I don't want to commit myself over this one. But usually, if the other value is either small or big, then you can round it off or round it down and then make a conclusion. But the question is, we don't have equality. Oh no, let me leave it. It's my assignment with statisticians. Just that I've never come across it. Any other?
Yes, I think if I can offer my 2 cents, right? Or my 2%. Yeah. So I think
I'll appreciate that.
It depends on the field of research. So in my arena, we would set what the p-value is. So we would say p is less than 0.05 to be significant. So if it is 0.05, then it means, by my criteria, it's non-significant. But it depends on the field of research or the field that we are talking about, and our criteria that we set at the beginning in our methods.
Thank you very much for the rescue. I really have a big assignment, but thank you very much for that. Hey. Yeah, because now the other one because we say p-value is less than 0.5 or p-value is greater or equal to 0.05. Those inequalities, yeah. Thank you very much, Doc, for that. Any other? Otherwise, I move to...
Can go on in the interest of time as well. Thank you.
Okay. Now, let us now consider 3 or more groups. That is we now jump to ANOVA, analysis of variance. We are interested, we have a number of groups, we have a number of classes, grade A up to C, over accounting, over whatever. Then we want to see if these guys really are performing the same way or differently, which one is higher than the other. There are different streams. There's history stream, there's a commerce stream, there's science stream. Now we want to see their performance over mathematics, to say the history stream is worse performing in mathematics, yet the science stream is excelling. Is that the case in your school? Let's try to see. Let's play around. Now, there we go. Here, okay, this is just something to assist you to say, okay, let me not even go here. Let me see which data set I wanted to load here. The data set for ANOVA. Let me see if I use the same data set. Yeah. Let me see. Let's take ANOVA here. Let's push wages again here. Push it there. Let's say health facility. I see. Looks like I projected. Yeah, that's okay. Let me quickly go back and see the number of groups I have here of facilities. Some guys coming from clinic, hospital, and traditional whatever. Yeah, these are 3 groups. These are 3 or more groups. Yeah. So we can do this ANOVA over these two categories. The last time we were doing student test over wages and gender, which is 2 groups. But now we have 3 or more. Let's take 3. Then we go ANOVA. We click it there, is over there. And then our variable of interest is the same wages, which could be the student scores or whatever treatment you have in your field, something like that, push it there. And then now we need the nominal variable here, which is health facility. There we go. But remember, we now have a table of results. The p-value is there and the f-value. There we can report, we are going to report the f-value, degree of freedom, as well as the p-value. But now, let us now check the key assumptions. Very, very, very important before you say anything. Then you check them, and then the assumptions there is homogeneity. That is one that is very key. If it is upheld, then you can go on. And usually normality is always there, usually. But according to this, if you are covered with homogeneity test, then you're covered indeed. Let's check it there. When we check it, there we go. This is Levin's test. Now, that is the key assumption. Now, we go back for us to be able to interpret this, the key assumption. Let's go back to the interpretation of Levin's test, so that we, sorry, where is that one? Levin, yeah, so that we are covered. It says here, if Levin is not significant, that is, the p-value is strictly greater than 5%, or that significance level, then this indicates or implies that the variances are statistically equal. But leave that one. It means we can proceed. It means the key assumption is upheld. You can take it this way. If p-value is greater than 5%, then you proceed. It means the key assumption is upheld. But if it is less, meaning it's significant, you cannot proceed with that ANOVA. It means the key assumption, the key assumption is not upheld. Therefore, think of something else. What it is post hoc. You can go further, because the moment you want to compare 3 or more groups over a single variable, if they are all equal in terms of their means, then case closed. If they are not, it means group A or stream A might be performing better than the other better. So you might be interested, who is who here? Who is outsmarting who? And to what extent? You want to go deeper. So post hoc can help us do that. Usually take his post hoc. All right. Now, let's go back now. We are saying p-value is greater than 5%. We proceed. Not, we don't. Let's go and check ours. Is the p-value in the key assumption greater or less? It's greater. Then it means we can proceed. If this was not greater than 5% or 0.05, then we would have a problem to say the key assumption is not upheld. We would resort to something else which is beyond the scope of this presentation. All right, now we can proceed. Now, when we proceed, we check. Let's move and see. Another point of interest is to say, we can proceed to say we were comparing the 3. Now we may do descriptive plot again to see what is actually happening. Let it load. There we go. There we go. Remember, we are comparing these 3 groups over one variable. There we go. The other mean or is here, the other one there, the other one is there. Immediately, even before you go the P thing, P confusion, you can see that the clinic guys are having good wages, if ever these are wages. Depends on what it is as far as your research is concerned. This is quite far than this. The 2, by the look of things here, are not actually that different. They don't differ that much. But this is a potential outlier. These guys are having it either rough or nice, depending on what it is. Any questions when I'm here? Time. I will have to leave here and move to contingency tables and the PET student t-test.
Thanks, Doc. I think some of the questions are related to accessing the updated slides.
Okay. Okay. Yeah, those are the ones that I circulated prior to this session. Because the ones that I sent previously were not really very updated. Yeah, whatever that I sent lately is really updated, up to date. Yeah, except where I typed.
Yes,
right.
sure.
Yeah.
And then there's just another one regarding the health facility example. And just where does it come from? If it's a combination of like survey related questions.
Okay, pardon, please.
So another question was regarding the health facility variable that you had showed.
Yeah.
So they're just wanting to find out a bit more about the origin of that variable. So it says, is that, for example, from questions from a survey?
Oh, no. This is just a demo. Like I said, this is just, what is it? This is just a demo to say, we are having 3 groups, and I've been making an example of you, one teacher who's a researcher who's having 3 streams. That is history stream, commerce, and science. That is comparable to clinic, hospital, and traditional. It is just for us to understand. And out of these sessions, one must be able to internalize these and take these examples and apply them in his or her, in one's field, and be able to proceed without any problems. The wages over there, it is just a dependent variable. In the context of teaching, that wage could be replaced with test scores, maybe in mathematics or in any field, in any discipline. If it is mathematics scores, then I want to compare these 3 streams, how they perform as far as mathematics is concerned. So that is another applicable, something that one can take. So basically, this is just a demo for us to understand. Not, it's what is it? It's just hypothetical data.
Thanks, Doc. I think we can proceed because we've got about 25 minutes left.
Oh, okay. Let me do that, please. Back to our slides now. Okay, this is how to report the results of ANOVA. You can say anything. Let me just say one way ANOVA analysis of variance was conducted to examine the effects of age group on whatever systolic pressure, but in our case, it was wages. The results indicated there was significant difference in wages, I'm just saying. And how you report the result. There is an F there in the table, degree of freedom in brackets. Then you put the F value and then the P value, then you are done. So that is how to report. You report the ANOVA in this particular manner. So please take that example and apply it in your own context, just for understanding's sake. Then we move to contingency tables. Let's use the same descriptive data, that is age versus, this time we take age versus gender. So now, contingency table, it takes us back to our demographic section, where we have gender, we have age groups, we have whatever. We are concentrating on categorical variables. We want to see, in this case, whether the age group, if knowing the age group is dependent on gender. That is to say, can we predict with some level of precision to say, if we know whether you are male or female, can we know your estimated age Is there any form of correlation? But let me not speak that language. But is there any form of link to say these two, they are somehow dependent on each other? Are they associated to some extent? We are now analyzing two categorical variables / nominal variables coming from our demographic section. So let's do that. Minimize this, click them. Is it the same data set? Remember how to total between these. This time around, we are taking the first two. Did I say age and gender? Let me check. That is age and gender, yes. We are taking, these are two categorical variables. You see those circles there. Now, this time around, we are doing contingency tables, of which these can be generated by your pivot tables from Excel. But the difference is you might present these variables in Excel using pivot tables, nicely so. But the question is, you might miss some interpretation because you are using your naked visual eyes. Here we are guided by some form of statistic, some yardsticks to say, indeed, and that indeedness is picked up by the p-value. Let me say that. So now, that is the difference of analyzing these from the pivot tables in Excel versus analyzing from here. Now, frequencies, you take your frequencies, then there's a contingency table there, sub-module there. Click that one. There we go. Is it freezing now? It looks like my system is freezing a little bit. My apologies. Ah, there we go. Remove that one. Now we are here. So now, I'm now taking age and gender. Now, this time around, it doesn't matter. Or now, if I push this as a row and push the other as a column, I might swap. It depends on orientation, what I want. I might drag and drop. You might drag this up there and take that one, pull it down. Doesn't really matter. You can play around. So therefore, all I want to know is some level of association between the two variables, so that I can say there's a strong association between the two. So this time around, we use a test called chi-square, the chi-square. So now, there we go. There are groups. Automatically, you can see that. Okay, let me do this. Yeah, you see the group, age group is here, 18 to 25, blah, blah, until there. Then the total sample size is 50. And then there's some distribution here. Then let me see when I put it like that. Yeah, just an orientation sake. Now, then while we are here, remember, if you were doing this from pivot tables, you would only have this, the first table, and your reporting would be based on the table. You would be writing a very long something, which is not a problem. I'm not saying it's a problem to say out of, what's the total here? Out of 100, yeah, out of 100 participants, 50 were females and 50 were males. That is what you're saying is okay. And then between the age of what you are reporting like that. Yeah, you are saying that, but if I'm reading this, you are writing what I can already see. So to break that monotony, to bring about something concrete and tangible, now put that table together with the chi-square. That will help you to check if there's some form of association between the two categorical variables. In this case, remember, if this is the test statistic, then we're interested in the p-value. If here we are saying we are testing some form of association between age group and gender here. So the p-value is significant. We are having significant outcomes here because the p-value is far less than 0.01, which is less than 0.05. So that means there's an element of influence between the two variables. So it simply says, knowing how old you are can give us a picture of what your gender is. So it depends on your research, and you must really understand your research in order to interpret that correctly, given the kind of variables that we're having. And where does it lead you to? Perhaps in the analysis of your demographic variables, when you go to other sections, you might, whatever you found from demographics, you might have to bring that along to say, much as the results are like this from other sections, then even the demographics, I see that most females 1 to 3, or most men 1 to 3, 1 to 3. Unlike just say many, and then what? You leave it like that, and then you report the other section. What about the insights you got from demographics? Then if you don't relate them, then that was just to push pages or just for cosmetic sake. That's another thing. So the chi-square is a yardstick to tell us if there is a statistical significant association between the two. So there is, because the p-value is far less than our significance level of 5% in this particular case. So we are done with contingency table, usually done by pivot tables from our Excel spreadsheet. The other one, okay, let me now show you how to report. When you report this, this is how you can report. Don't worry about the wording, but concentrate on the APA format of providing the statistical report here. A chi-square test of independence was conducted in order to determine, whether there was significant association between our age and the age group, as well as what? It was age group as well as gender in that particular case. But I'm just reading this. The result revealed a statistically significant relationship. The moment you say that, which was the case of our p-value, which was far less than 0.01, then you drop the chi-square. Then degree of freedom, it was 6. And then the value of the chi-square in this case is this, and then the p-value, you report like that. But if I was to take the results as they are from here, let me do it quickly. Quickly here. Then take that there, and take this here. You write chi-square, and then our chi-square value here is 100. There is 200. Our hours here, between these two categorical variables, our chi-square equals
Hi, I think we are experiencing a slight technical glitch.
0.001. So that's covered. This is to our usual pivot tables generated from pivot tables in Excel.
Dr. Bernard, I think we're experiencing some technical challenges. The audio is freezing and the video is freezing from time to time.
Hello. Looks like a cut. Hello.
Yes, hi, you're back. Thank you. You are back.
Oh, okay. Thank you very much. All right. Now, I'm moving on to.
Sorry, Doc, your screen is not being shared, just to let you know.
Okay, let me reshare.
And if you can repeat the last few sentences, because I think there was some kind of interruption.
Okay.
Thank you.
I don't know. I said a lot of things here. Where was I? Was I giving the reporting?
Yes, I think if you can go to the reporting, that would be great. Thanks.
Okay. With this one, remember we are testing some level of association between these categorical variables, age group and gender. So Much as we can say anything here, number of females, blah, 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 there's no problem with that. But what is important is for us to know if there's some form of association between the two. So for us to be able to know that the test, the chi-square test, is the one to give us conclusion right there. So we see that once the p-value is significant, statistically significant, then we can say indeed there is some relation, strong, not strong, there's a statistically significant relationship between the two variables because the p-value is far less than 0.05. It's already less than 0.001, which means is again less than 0.05. But when we report, we take the chi-square as it is. We write this sign, the chi-square, bracket, degree of freedom, and the value of the chi-square is 100 in this particular case, and the p-value, we write it as it is, p less than 0.05. That is what we drop in our report. That's all. On top of what we shall have said based on this table. Blah, 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 group this one, but it's okay. But of interest is this. All right, now quickly, I jump on to correlation analysis. The correlation, the correlation analysis. In this case, this type of analysis is done when the goal is to examine the strength and direct relationship between two continuous variables. We want some relationship between the two variables. Maybe if you're in climatology, you want to see if there's a form of correlation between the sunspot numbers and your climate, the key climate variables. Maybe rainfall, weather rainfall, and the sunspot numbers are strongly correlated, either negative or positive. So that is another thing to check. Once the coefficient of correlation is between these values, there's weak or negligible strength between 0.2 and 0.39 is weak. That is very weak. That's weak, moderate, strong, and very strong. And even the negatives are applicable. When the correlation coefficient is negative, it means when one variable increases, the other one decreases. But the association there could be strong depending on the value of the coefficient, correlation coefficient. So let's do that. Now we are going to use the study hours data set and then do the correlation coefficient. We do that, you click there, let me close this one. Do I want to save it? It's a no. Let me go to my computer, then I go there, study hours, you click there, open, the data is loaded. I have two continuous variables. Remember those variables are on scale as far as TSP is concerned. Now, you can see there's no problem with that. Now I'm doing correlation analysis. It is here in the module of regression module. You click there, you'll see a correlation, just correlation in this case. There you go. You can push all these variables, all of them here. They're all acceptable here. There's no condition. Now they are pushed into, now we have the coefficient. Pearson's correlation coefficient is parametric, like I said. But now, remember, before we can report here, it's important to check our blind spot, which is what? The key assumptions. Check. You click here, and then how many variables do we have here? We have two variables. Most probably we'll go for pairwise normality test, which is maybe varied in a way. You check that one. If we had more variables, we would go for the multivariate Shapiro-Wilk normality test. There we go. Then remember, if the p-value in the normality test is non-significant, there is no deviation from normality, meaning the key assumption checks. are upheld or check is upheld. Therefore, we can proceed with the analysis. So we can proceed with Pearson as parametric test. But if this was significant, then it would mean that there's a violation of normality test. And therefore, I would opt for Spearman, which is non-parametric. There are no assumptions. And then I do reporting straight to say there's a significant correlation between the two variables. Then if there's a significant correlation because of this p-value, then how strong? Then it is 0.86. Then I go back just to interpret. 0.8 is a very strong correlation and strong positive, meaning one increase in one variable results in an increase in the other variable. So what is this data set that we have? We can go back and see what is it that we have. We have study hours and exam score. It means if you spend more hours in reading, there will be more, there will be good scores. Let me say that. Good number of hours spent in studying, you'll get more marks. That is up. That is a positive direction. Both are positive. If it was 0.86 negative, it would mean an increase in the number of studies would result in a decrease in the score, in the test score, exam scores. Still strong, but in the opposite direction. So the sign gives us the direction, and the value gives us the strength, how strong the correlation is. Any questions? Now, PET test. In this 6 minutes left, PET test. With the PET test, when do we do it? It is done when the same individuals or matched units are measured twice. Usually, this is normally done in monitoring and evaluation studies. If we want to check the pre and post, before intervention and after intervention, if you are a teacher like I am, you are teaching learners or students with a particular methodology, but then you want to change, or you heard from literature that a particular methodology can result otherwise. Then you teach with this particular method, and then the same set of students, you now apply another. In other words, you are going to see pre and post, or you can have control and experimental group and check if there's a difference, depending on the type of study that you are doing. But usually, this is for pre and post, for monitoring and evaluation purposes. So it's a PET and t-test. So let's go, let's load data set. But now we must be able to interpret this. Now, if our p-value is significant, that is less than our 5%, we conclude that there's a significant difference between the two PET measurements, meaning your intervention has actually worked. If it was an intervention, if our p-value is greater or equal to that very value, then it simply means that there is no statistically significant difference between the two PET measurements. That whatever intervention that you have made, it has not amounted to anything. It's as good as you have not done anything. So it's very, very, very important, usually in monitoring and evaluation or impact studies. So here we go. Let's go and load the stress data set quickly. And this is the last one. We go and let me close this one. Let me not save it. And then the recent files. No. Computer, I'll do that. This one is what? Is stress scores. We have participant number. This one is not of interest. We have stress before an intervention and stress after. So this is just to demonstrate the PET t-test. So where do we get it? around the same t-test module. You click there. Remember what we did then with the two groups, comparing them over one continuous variable. We did independent sample t-test, but this time around, we do the PET sample test t-test. Then you click there. So the variables of interest are these. That one is just participant ID number. You push them there. We have the results. But remember, blind spot, key assumptions test. Then we check. But we also need to be careful here. What are we saying? We are comparing what is it? One group over one variable, but at different times, if I make sense. So therefore, let's check assumptions. Remember, even if at this moment, this is just, what is it? Fundamentals. I wouldn't take you through this, but I'll check it out. But so far, we have this. All right, normality test. Then we see. Forget about this a little bit. Let me not even check it for now. Residuals, another thing. Let's check here our normality Shapiro-Wilk or Werk, and then
Dr. Bernard, you've frozen again and there's no sound. I think let's give Dr. Bernard a moment. Sisonke, are you able to hear?
Hi, Inba. Yes, I can still hear you. I think
But
the
we can hear
connection
you.
is
The problem is on his side.
is
Right.
loud.
Let's see if
Yes.
it's trying to reconnect.
okay,
Apologies.
I'm here. It's back.
Thank
I'm
you.
left with 1 minute. There we go. Without necessarily going to the other check here. Remember, if one of them is violated, then for now, we have been concentrating on this one, not the QQ plots. So once we are here, it says there's a deviation from normality as far as this particular test is concerned. We must be mindful of how each p-value is interpreted per statistical test. Very, 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 very important. Otherwise, we might create confusion. For with JSP, you are assisted. You are assisted like you already have some nodes around it. In which case, I'll not say all. I've not explored all statistical packages, but others, I find them very difficult. This is user-friendly, and it's so good that it even assists you to write proper reporting. So therefore, there's a violation here. Therefore, is a no-go area. And if that's the case, then let's go non-parametric. Check that out. We don't care whether the assumption checks are held or not, but we just interpret the results. So the p-value is significant. Remember, we are trying to check whether the before intervention and after intervention are actually different. We want to see if there's a statistical difference between the two, if ever we have made an impact or not. So we see that our significant value is very significant, which could tell you that whatever intervention you did in this particular undertaking has brought about good results. And if you so want, you can check the descriptive plot there. And once you check it up, you can see now, as opposed to the initial analysis where the means were almost this, I don't know, let's call them bars, or let's call them bars. The bars were almost around the same horizontal line, but this time around, there's a big shift. One is higher than the other. So it depends on the type of intervention that you're undertaking. If you are reducing, the aim was to reduce whatever, then in this particular case, it means the stress level after has actually lessened. Maybe people were canceled in this particular study. Before canceling, people were seriously stressed. And after canceling, indeed people were less stressed, where people were really dancing. And indeed, I'm embarking on such a new career where I want to be a DJ. All right. All right. Just to relieve stress. Just watch out space. Now, here we are. Just when you look at this, we are fine. So meaning that the intervention has really worked. But we might be interested again to see the effect size. And we know it's here. Check it out. You check it out. The effect size must be loaded there. Where is it? Where is the effect size? I've just checked it. Did I? Let me see. Should be eta. Oh, let me see. There we go. I want to check the effect size here. Why can't you see the correlation by varied correlations? I don't know what is happening here, but I think I've made a point with the descriptive plot. With that said, time is not on my side. Let me say this is the end of my presentation.
Thank you so much.
And exactly 3 minutes after the specified time frame.
Thank you so much, Dr. Bernard or DJ Bernard.
Guys, I'm coming.
With that, I think we've only got enough time to thank our presenter, who's done a sterling job of introducing everyone to JSP, and who has spoken about the various forms of parametric and non-parametric testing. I think, Doc, judging by the chat, you will have to come back perhaps in the next training session next year and speak about Bayesian statistics and speak more about p-values. There's a lot of interest in that. And finally, I would just like to mention for everyone who registered to please do go to the online platform to access the learning materials, which Dr. Bernard has shared. And then lastly, if you all would please fill out the module evaluation form, because we really rely on that form to guide us in our preparation for these sessions. Sisonke, would you like to add anything before we jump off?
No, I think you've captured it all, Inba. I think you've captured it all. Thank you.
So we'll give Dr. Bernard the last say ahead of his DJing career. Over to you.
Thank you very much, Madam Program Director, and thank you very much to all of you participants, attendants. I really am grateful for this particular support. It's really appreciated that you forwent your activities just to come and get some insightful information from this session. I really appreciate that. And please watch out on my DJing career to just minimize the stress levels of research.
Yes, the p-values especially. Thank you so much. Please remember to fill out the evaluation form.
Okay.